sometimes get like shaky hands. I've never done it, but I've
All right, everybody. All right, we're getting ready to start. Thank you for coming out for our performance event tonight, and thank you for making it the biggest one we've ever done. So, a couple of things to know. The way it's going to work tonight is we have 3 speakers. After the speakers, we're going to have some dinner. It's going to be tacos. We fought for better food. We got you better food. After that, Colt McCandless from Google is going to do something that if you've never seen someone do before, is pretty awesome to watch, which is dissect sites for their performance. That's going to be great. The first speaker tonight, make sure you're all on the wireless. Did everyone see the web page they were supposed to go to? Jake will remind you. This is going to be an interactive one, so get your phones ready to connect to that site. There's going to be quizzing, there's going to be answering, there's going to be minds blown like, wait, that's a thing? Then we're going to have Eitan talking about the New York Times, and we're going to be having Adam Grossman from Forecastio talking about Forecast.io or Forecastio?
It is not Forecastio.
It is Forecast.io?
Just Forecast.
Just Forecast. Okay, it's just Forecast, sorry. Which if you haven't looked at, you really should. But first, Jake Archibald from Google is going to give his excellent quiz. Oh, one more thing. Sorry. Bathrooms are on the sides if you need to. And anything else, Chris? Did I get it? Okay. Jake Archibald from Google.
So yeah, this is going to be a quiz. So if you're not on the Wi-Fi, get yourself on the Wi-Fi now. The username and password is on there. And then once you've done that, if you want to go to this URL and make up your own username and password. So yeah, obviously not the same username and password, or a bunch of you will be on the same account. So yeah, you won't be able to get to that URL if you're not on that Wi-Fi network. So make sure you are. And if you're watching this on the live stream, tough luck, I'm afraid. You've just got to play along using your brain, and you can write things down on paper and score yourself if you want. So the reason I'm asking you for a username and password is just so you can switch devices halfway through in case your phone starts running out of battery and you want to switch to your laptop. Just use the same username and password and everything will work. The password is stored in plain text on my machine, so don't use like your credit card number or anything like that unless you are intending to make a donation, and that will be gratefully received. Thank you very much. So I'm going to assume everyone's ready to go. I will keep the URL in the corner of the screen, so if anyone loses it, you'll be able to pick it back up. I kind of hacked this together on a plane. You could probably break it by trying to break it, so please don't try and break it. I've made it so little Bobby Tables can play. That's not going to break it. But there are probably other things you could probably DOS it, so please don't do that. And I want to stress that this quiz is pretty tough. I've seen it get the better of people who do this kind of study of browser quirks for a living. So if you're the kind of person who gets really angry and starts flipping over tables when you don't win, then just maybe stay away from the tables for a little while. Okay. Of course, what kind of quiz would be complete without a prize? So, the Chromebook Pixel is Google's latest laptop, featuring an i5 1.8 GHz dual-core processor, 4 GB of RAM, and a touchscreen with a higher DPI than a MacBook Pro. Couldn't get hold of one of those, sorry, they wouldn't let me. But what I did get is a Chromecast, so I've got one of those to give away for whoever gets the highest score. So it's not quite a Pixel, but it's very, very good. So let's start off really simple. And so the URL's there in the bottom of the screen if you need it again. But here's a nice, easy start. You've all worked with images in HTML, right? Okay. So here's a div, but it has a source like an image might. Which browsers do you think are going to make a request for that image? Now, on your phones or on your laptops, you should be presented with the options. So you pick which ones you think are going to make a request and then hit submit. If it's not appearing on the screen or the icons aren't, you can just give the page a refresh and that should come through. When we're talking about these browsers, I mean the latest versions of each one, so IE 10, et cetera, et cetera. You get 1 point if you get it right for a particular browser. You lose a point if you get it wrong for a particular browser. So there's a maximum of 4 points per question and a minimum of -4. You can score negatively. You can assume the HTML5 doc type, and there's nothing hidden going on. I'm not going to turn around and say, oh, but there's a base element that's changing the URLs. There'll be none of that. It's just what's there on the screen, that one line. So what we're seeing here is like a live opinion of the room as well. So the needle swings one way when you're saying collectively that yes, the browser will make a request. It will swing the other way if you're saying no. But I'm going to randomize which way is yes and no for each question, so you can't just look at the screen and vote along with the room. Okay, so that's probably enough time. I'm going to close the question in 3, 2, 1. Okay, so we can see from this that you're sort of saying Chrome is going to make a request here. You're less sure about the other browsers. And the answer is no. None of the browsers are going to make a request in this. But it's not actually as mad as it seems. So this doesn't work in HTML5, but it was proposed in XHTML2. So XHTML2 allowed you to do this, put a source attribute on anything, and it would replace the content with what you had in the source. And this was really good because it meant that the alt attribute on images became redundant because you could replace real semantic content. Pretty cool idea, but XHTML2 was backwards incompatible, and it carried with it XML's draconian error handling. And once you invite XML into your home, it XMLs everything. You know, XMLs all over the floor, up the walls. And in the same way that Smurfs stick the word Smurf in front of everything to make it a Smurf thing, XML does it with X. You know, like, you don't want HTML, you want XHTML. You don't want frames, you want X frames. You don't want forms, you want X forms. If you let XML take over your life, it will turn your boyfriend or girlfriend into an ex-boyfriend or girlfriend. And XML's cool with that because, you know, you don't need a partner anymore. You've got XML to look after you. It seems fitting that in 2009, XHTML became an X specification, and it was completely abandoned, and no browsers ever implemented that source attribute on elements other than like images and the things they work on now. Okay, but what about this? So here we've got an image element. It's got a source. It's in the page, but I've spelled image incorrectly. I've put it IMAGE rather than IMG. Does the browser treat it as an unknown element, or does it make the request? The browser only has to make the request. It doesn't have to display it on the page, in case you think that matters. XML was too strict to work with the web, but is HTML this lenient, or are the browsers more lenient than the spec? Just get your answers in quickly. I'm going to close the question in 3, 2, 1, and it's closed. So we're kind of edging towards no in all of the browsers. All of the browsers will make a request for this image, and they will display it. Because in the past, a browser decided that IMG is quite difficult for developers to remember, so they should support IMAGE as well. And we've been stuck with it ever since. Which browser engine do you think we've got to thank for this? Yep, you've guessed it. It is Mosaic, back in 1993. The people who invented the image tag, they put this alias in, and a study in 2005 showed that 0.2% of pages were using this misspelled image tag. So any browser that wants to work on the web that we have today has to duplicate this alias. The WhatWG recognized that, and they added it to the spec. This is the parsing spec. You know, start tag, name image, change the token to IMG, and reprocess it. Don't ask, which is great. But this was actually used in a clever hack recently. Alexi 10 came up with this, which I really liked. You would use this in place of your image elements. And what it does is it loads an SVG for browsers that support SVG, and it loads a PNG for browsers that don't. So the way a modern browser would parse it is it sees SVG and it goes, okay, it's got a width and height of 100%, well, 100 pixels. And it sees this, and it sees this as an SVG image element, because in SVG, images are spelled out full rather than IMG. It's got a width and a height, and I'm going to load this, because this is how you define the source of an image in SVG, because, you know, why have links when you can have X links? So, and then it sees this, and that doesn't mean anything to SVG images, so it's ignored. So we're now showing the SVG image, and all the browsers, such as Android 2 or IE8 and below, they will parse it like this. No idea what that is. I'm going to ignore it. I'm going to treat it like an unknown element. Oh, look, the developer has spelled image wrong. It's OK. I'm going to correct it for them. It's 100 by 100. No idea what that means, so I'll ignore that. And then, oh, there's the source of the image. I'm going to download the PNG. So it's kind of nice because it doesn't require JavaScript, and it's a nice way to conditionally load the kind of file that the browser supports. We got quite excited about it, and we were tweeting about it. The mistake we made is we did not test it. So a few of us did just that, and we found out something interesting. All of these browsers support SVG, but which browsers will download the PNG as well? And I'll give you a clue, it's not all of them. Not all of them get it wrong. It's just one or some of the browsers are going to get this wrong. And they'll end up downloading both the PNG and the SVG. I'm going to close the question in 3, 2, 1. Okay, so we're saying no in all the browsers, and yes in IE. It's almost like you've been burned by that browser in the past. Well, the answer is you are right. Internet Explorer will make a request for 2 images here. And this is because all modern browsers, they've got 2 parsers built into them. It's a relatively new thing for them to have, but they all have it. One parser runs ahead, and it goes and it tries and finds things like it should download, like scripts and images and whatever. And then the other parser comes along and does the heavy lifting, like building the DOM tree, parsing scripts, etc., etc. And this has a really large benefit. A study we did at Google, we looked at 2,000 sites, and when we added this preloader, and we got a 20% speed improvement to get to DOM content loaded. So it's really useful. But in order to be quick, this pre-parser is a little bit stupid. And in Internet Explorer, it's a bit too stupid at the moment. It kind of gets overexcited. It's like, oh, look, I'm going to show this PNG. I'm going to show this PNG. Here I go, showing the PNG. Oh, no, actually, I won't. I can say it's actually an SVG. I'll do that instead. So the main parser sees the markup, and it sees the image, but it misses the SVG context. And then the main parser comes along and goes, well, why am I downloading a PNG? And it cancels that download and goes for the SVG instead. But by that point, it's made the connection. It's probably got all of the image by that point. The moral here is don't trust performance tips. Make sure you test things. At Chrome, we say tools, not rules, which rhymes, so I guess it must be true. But always be on the lookout for existing data or existing tests that you can run. One of my favorite stories in science, or a tale, I don't know how true it is, but it involves this man, August Weismann, and he wanted to disprove that life experience was part of evolution, like something that happened to you during life would be passed down as evolution. So the way he was going to disprove this is he took 2 mice and he cut their tails off and bred them together, and then he took the offspring there and he cut their tails off and bred them together. And the idea was, like, we shouldn't end up with mice being born without tails, right? And he was running this test for quite a while until one of his colleagues pointed out, it's like, August, you do realize that Jewish people have been inadvertently carrying out this experiment a lot longer than you have. And I go, oh yeah. So he stopped his test and he would just use that as evidence. So what about this? We've got a div, it's displaying none, there's an image inside it. So the image won't be displayed, but which browsers are going to download it anyway? So yeah, it's not going to render. So you could say it's a waste of bytes to do so. Or maybe some browsers are going to get it just in preparation, thinking it might be shown. I'm going to close the question in 3, 2, 1. OK, so we're sort of leaning towards yes for every browser. We're quite certain it's going to happen in Internet Explorer. The answer, collectively, you are correct. Yes, all of the browsers here are going to download that image. And this behavior is part of the spec. So in the browser, in the beginning, there is nothing, and then the browser gets sprayed with HTML text, and it will convert that text into a tree of elements that we know as the DOM. When this HTML, when an element is turned into, when a tag is turned into an element, the construction steps for that element are run. And for image, it's really complicated, actually, creating an image element, but step 14 down here at the bottom is where it actually makes the request and requests the image. So visibility doesn't matter at all. It doesn't come into it. And that's kind of good, because it means that your images can download before your CSS is downloaded, before your scripts have downloaded. As a downside, it meant that responsive images polyfills did not work, because by the time your JavaScript gets to the image, it's already started the download of the thing that was there already. You're just going to add a second download by changing the source. This won't be a problem in the future. The resource priority spec, we've specified the postpone attribute, which tells an image that it shouldn't display if it's displaying none, among other things. But what if we are using CSS? What then? So here we've got a div that's displaying none, and inside there's a div with a background image. So it's kind of similar to the image one, but we saw that images are ignoring CSS. But here we're actually in CSS land already. So are there any browsers that are going to download that, or are they just going to ignore it? Because once again, it's not going to be displayed. So you could consider it a waste of bytes. I'm going to close the question in 3, 2, 1. So we're kind of edging towards yes in every browser. I'm afraid not. No browsers are going to download it here, none at all. And that's kind of, I suppose you could see that as a good thing. It's saving bytes. But what if we did this? Similar question. It's a div, display none, and it has a background image. So the difference from the last question is it's all on one element. It's not, the image isn't inside another element that's displaying none. Does that change things? Once again, it's not going to need that background image. I'm going to close the question in 3, 2, 1. So we're edging towards yes in every browser, a little bit more confident in Chrome. Most browsers will. Firefox will not. So what's going on here? So once the browser has this tree of elements, it needs to work out what they look like and where they go on the page. And the first step of this is a style calculation. So it calculates all the styles. It goes through the CSS cascade, the style attributes, the font tags if you're from the 90s, and works out what style applies to each element. But not everything gets its style calculated. So this div up at the top turned out to be display none. The browser stops there. It doesn't calculate for the children because those elements have no impact on the rendering of the page. So it's shortcuts. So if these elements have a background image, the browser just never finds out about it. This div up at the top here is display none, but it did have its style calculated in order to find that out. And that's when the browser will discover the background image. Firefox is a little bit smarter here and avoids the download. But if you change that to, instead of display none, you use visibility hidden or opacity 0, Firefox would download as well. Who's getting it right according to the specification? Everyone is. The spec is really vague here. It says the browser may optimize, even if the element is just obscured, it's underneath another one, but no browsers are that smart. This kind of freedom in specifications is kind of good, because it means the browser can do the right thing given the device, the connectivity, maybe even the battery percent, how much battery you've got left. But it's also scary as it means you're going to get the browsers doing different things as they try new stuff with that freedom they have. But I think that kind of diversity is what makes the web great. It's not one company driving forward with its own interests. It's lots of companies driving forward in different directions. And we get this kind of car crash, but with a happy ending. And that's the web that we have today. If you want to avoid downloading a CSS background, hiding the element isn't enough. You need to put it inside an element that is display none. But when you do this, you're just relying on what browsers do today. It's not specified behavior. Browsers may change. The only surefire way is make sure the browser doesn't find out about that background image. Don't add the class name that adds that background, or don't add the element to the DOM at all until you really need it. OK, things have been relatively easy so far because we weren't involving JavaScript. So let's get JavaScript involved. What about this? I'm creating an image. I'm giving it a source. I'm not putting it in the document, and I'm spelling image incorrectly like we did before. So we saw in HTML that it was auto-correcting IMG to IMG, but does it do the same in the DOM? Do images even download when they're not in the document? Because once again, the browser doesn't need to render this yet, or it can't render this yet. I'm going to close the question in 3, 2, 1. So this is the point in the quiz where the audience just gets broken and the needles just drift towards the center of like, I don't know what's going on. In this case, most browsers will download, Firefox won't. And there are two parts to this explanation. As we saw before, the DOM gets parsed and the creation steps of the elements are run. This animation took me a long time, which is why you've seen it 3 times already, but that is the last time. But when an element's just created using DOM stuff, it's still going to run the creation steps. And we saw for images, step 14, that is going to be when it downloads the image. We can use this to our advantage because this one line, you can make a GET request to anything that the machine can access. And in fact, images have their own DOM constructor, unlike a lot of other elements. So that tiny bit of code, instant GET request to anywhere else. And this is pretty much how Google Analytics talks back to the server. But we saw before that Firefox didn't make the request. So what's going on there? When we create this, most browsers, Chrome, Safari, IE, will give us an HTML image element back, whereas Firefox will give us an HTML element. It's not an image. If you add it to the page, it won't display an image. And the interesting thing is here, it's the only one getting it right. We saw before, this is how the browser, how the spec deals with images that are spelled incorrectly, but this is in the parsing spec. And we bypassed parsing by using create element. We're completely bypassing the parser. So it should, well, Firefox gives us an HTML element. It should give us an HTML unknown element, which it does for if you do create element foobar. So Firefox is doing something special for these images, but it's getting it more right than other browsers. I think I preferred it when we were developing for browsers. It was like there was one bad guy, and it was Internet Explorer 6 or 7 or 8, and all the other browsers seemed perfect in comparison. But I see the browserscape as being like an orchestra, where Internet Explorer 8 was just this kid hitting 2 cymbals together and screaming. But once we finally kick the screaming child out of the room, and we come back and we start conducting again, we realize, oh, everyone's actually a little bit out of tune. We just didn't realize because of the screaming cymbal child of Internet Explorer. So let's get CSS involved again. but JavaScript as well. What about this? So I'm creating a div, giving it a background. It's not in the document, but everything's spelled right and valid. We saw images download at this point, but what about when CSS is involved? Are we going to see things download there? Get the answers in quickly. I'm going to close the question in 3, 2, 1. So once again, the needles just drift into the middle. The answer here is no. No browsers will download here. This is the same as the display none case. The browser won't calculate the style of elements that are display none, and it also won't calculate the styles of elements that aren't in the document, because there's no point. It doesn't affect the rendering of the page at all. OK, I'm going to be cruel now. What about this? So same again, I'm adding it to the document, then I'm removing it again. Is it in the document long enough for the browser to go, oh, I should download this background image? Or does it not get to see it long enough? Does it not bother? I'm going to close the question in 3, 2, 1. OK, so we're suggesting yes, because yes, it has entered the document. I'm afraid you were all wrong with that one, or the people who said that. The browser doesn't want to think about styles or layout until the very last moment. And that's normally rendering, when it actually needs to change pixels on the screen. And we can't do that, or we don't do that, while we're in the middle of JavaScript. So the browser actually sits back and waits for that JavaScript block to execute. And then afterwards, it will go and look at what's changed and react to that when it needs to render next. But does this change that? So same code again, but in between adding and removing it to the document, I'm going to ask for the text content of the element. Now, the text content is going to be an empty string because it is an empty element. But is just accessing that property going to change things? I'm not even assigning it to a variable. So, is it just even going to be optimized away as a bit of JavaScript because it has no impact? I'm going to close the question in 3, 2, 1. Almost dead in the middle. Excellent. The answer is no. No browsers will make a request. Getting the text content is easy. It's just going to go through the DOM, find the text nodes, concatenate their values together. What about this? Similar question, but this time inner HTML rather than text content. Once again, it's going to be an empty string that comes back there because the element is empty. But does it behave differently to text content? Are the browsers going to do something different? I'm going to close the question in 3, 2, 1. So we're saying no here. Yeah, you're mostly right. Internet Explorer will make a download here. And the reason for that is because when Internet Explorer, I don't know. I have absolutely no idea. Some things in the world cannot be explained, and this is one of them. Like how it takes 3 attempts to plug in a USB cable, even though there are only 2 possibilities. Some things cannot be explained. OK, so on the same theme again, but this time in a text. Once again, like the other 2, this is going to come back as an empty string because it's an empty element. But is that going to behave differently? Is Internet Explorer still going to make the request erroneously like it did before? Is it going to get it correct this time? Who knows? I'm going to close the question in 3, 2, 1. So we're edging towards no. A little bit less sure in Internet Explorer. The answer, yes, most browsers will make a request here. And this actually kind of makes sense in an odd way. Let's make a div. It's got a background image, and it's got some inner HTML. It's got hello world inside it, but world is inside a div of its own. We add it to the document. We ask for its text content. It's hello world. But when we ask for the inner text in IE, Safari, and Chrome, it's going to return this. It's got a line break in the middle. And the reason for this is inner text isn't just the text content. It's more like what you would get if you highlighted the element and copied it. And because of this, it's got like style information, because the world is on a different line because the div is block level, or it is by default, and it is in this case. So what actually happens here is the browser, we ask for the text content, it just gets that back. But when you ask for the inner text, the browser has to go, I need to know what the layout of this element is in order to return this. I need to find out if that div's block level, where am I going to put my line breaks? Oh, look, there's a background image there. And then it downloads it, because it forces it to look at the styles. Most of the time, the browser will defer looking at styles as late as it can, but here we forced it to happen sooner because we've asked for something that's style dependent. Firefox didn't make a request because it doesn't support inner text. It doesn't support the property at all, so that's just undefined. That was quite cruel. But if we used any of these properties, like outer text, no, not outer text, but offset left, offset parent, Firefox would have made the request as well. Sort of ignorance of that, those elements that will require style information, that's one of the number one problems with performance that we see on the web, but it's also you can do some nice hackery with it. I mean, if you look at code like this, it looks really expensive, but it's not. It's really cheap, because the browser's just going to sit back and watch you just writing this property to an object, and it's not going to care about it until that block ends. And once that's all done, it will just look at the result, and in this case, there's no pixel difference. This can lead to some unexpected results, not just graphical performance. But so imagine, let's have a look at a practical example. Here is Paul Lewis and me, who we work together. We want to go over there. You can tell because we're pointing. But let's do it with code. We're going to say left 0%, we're going to set a transition, and then left 100%. If we run that code, hey, off we go. Excellent, we win at code. But if we run that code again, nothing happens. And the reason nothing happens is the browser's going to batch up these style changes. So we're setting left twice, but the browser's only going to listen to the last one. And we're essentially saying transition to 100%, but we're already at 100%, so it doesn't move. You might have encountered this and tried to fix it with set timeout and an arbitrary number in that. But what you actually want to do is at this point, just after we set the first left, you want the browser to go and look at that style and actually think about it. And we can actually do that by putting one of those properties in, offset width, or whatever. And once we do that, we can run that code as many times as we want, and it will work every time. But you are relying on unspecified behavior when you do that. The Web Animations API will save us there. And just before I get kicked off stage, I want to go through the bad side of that. Normally, using things like offset width in the middle of your code can lead to a performance difficulty, and here's an example of that. So here I've got a page with a load of paragraphs, and what I'm going to do is I'm going to set Chrome's timeline recording, which is going to record everything that's going on, resize the screen box, and I'm going to hit that button. When I hit that button, all of these paragraphs are going to become the same size as the green box. So do that, press the button, and they all change. And that was quite slow, and we can see in the timeline there's a little spike there. And if we have a look at the number that comes up there, it's like 1.27 seconds. It's very slow. But there's this little warning icon on there, and if we kind of look into that, we get a clue of what's going on. We get this recalculate style layout happening over and over again, and that's not looking great. The code we're using is really simple. We just loop through all of those paragraphs and set the offset width for the green block to the paragraph. Now, the first time we go through this loop, we ask the browser, what is the size of the green box? And it goes, oh, I know that answer, because I've just drawn it. Here's your answer, easy peasy. And then we set the width to the paragraph, but the next time we come around the loop, we ask the browser, what's the width of the green box? And it's like, I used to know the answer to that question, but since then, you've been playing around with styles on the page. So I need to go away and have a think about what you've changed and see if it affects the width of the green block. And that's going to happen on every loop. This is layout thrashing. This is interleaving style reads and writes, and it's a performance killer. What we actually want to do is just cache that, do the reads first outside the loop, get the green box width, and then go through the loop. And the difference is absolutely astounding. So recording that, changing the width of the green box, click the button, it just happens instantly, and it's a massive difference. And that was like 60 milliseconds all in for everything versus like over a second. So if you need to read something that's style dependent, do it before you start making style changes. And am I out of time? Am I done? Okay, but before we do that, we'll have a look at the final scores and see who managed to win the Chromecast, if I can get a mouse pointer over here. Right. A moment of tension. Where's my mouse pointer? Let's see if this works. Okay. Oh, we've got a draw. That's how many? We've got one Chromecast. We can get another one. That's excellent. I do have a bonus round, but we're definitely out of time. Who's where are these? Where are you two people? Where are you? Oh, one here. And there. Oh, congratulations, guys. A round of applause for these guys, actually. And with that, I say thank you very much, and I'm going to make way for someone else. Thank you very much, guys. Cheers.
Thanks, Jake. That was great. All right, our next speaker is the New York Times own Eitan Konigsberg. He's a front-end architect, and he's going to be talking about history of performance at the Times. Good. Okay.
Hello. All right. Hey. So, hi everybody. My name is Eitan Konigsberg. I'm a front-end software architect here at the New York Times. Today, I'm going to be talking about the very real history of our web performance efforts here at the New York Times. Before I dive in, I wanted to share with you this tweet by Steve Souders himself. If you're not familiar with Steve Souders, it's the place to start when you're talking about web performance. He tweeted, "Is performance of the web getting better or worse? My past week was painfully slow, marred by top sites with bad web perf. Is it too hard?" I don't know if the New York Times was among these sites that Steve was having trouble with. We've known that we've had a little bit of a performance problem. I like to think that he's checking our site and he's actually complaining for real that our site is slow so that we make it fast for him. But I'm going to get back to this question about whether it's too hard. So while I was preparing for this talk, I was thinking that this is a very real story, and it reminded me of a Geico ad from about 2006 that I just kind of wanted to share with you. So just give me 1 sec to play.
Paula Sela is a real Geico customer, not an actor. So to help tell her story, we hired that announcer guy from the movies.
When the storm hit, both our cars were totally underwater.
In a world where both of our cars were totally underwater.
We thought it would take forever to get some help.
But a new wind was about to blow.
With Geico, we had our check in 2 days.
Payback. This time, it's for real.
Geico. Real service, real savings.
So I thought about doing this entire talk in movie announcer voice. I didn't think I'd be able to keep it up all the way through. Colt is actually the expert at that, so you should check out his talk on National Talk Like a Pirate Day. That was actually really great. Kudos. So, in a world of static pages, pages on our website are published basically like you would a newspaper. Somebody hits a button, and the content goes through templates and is written to disk. And we mix it with a proprietary language that we compile to give a little bit of dynamicism on the server side, and it was fast. We have about 1 million of these static pages since 2004, and republishing them is really not an option for us. If hypothetically it took about 5 seconds to republish one of these pages, 5 million seconds I think comes out to about 2 months. We can't be doing that every time we make a change. So what ends up happening is it's extremely hard for us to change markup once it's been published. And every time we make a change, it's only present from the day we deploy it onward, which means we have an unknown number of permutations of these markups to handle and support over time. So our front-end assets, our JavaScript and CSS, have to handle all of these permutations. And in order to be able to change these files, since we can't change the asset path because the HTML is static, we have to keep the time to live, the cache expiration timeout, very low on these files, which is a performance bad practice. And we also don't really know what pages on the site call which assets in general. So I want to talk about our CSS history. We didn't really have a CSS framework, which means we have a lot of repetitive styles. Files were imported basically as needed. Style sheets approached the import limits in IE, 31 total, and maybe up to 3 nested levels deep. There was inconsistent load style. We were using link tags in one case, and right after it using a style tag with an add import directive. And basically, we also have to deal with web producers who go through and they're able to modify the look and feel of our page on the fly as the news happens. So they can be dropped into our content system and appear anywhere on the page. In the JavaScript department, JavaScript was very ad hoc. Since most of the dynamicism was on the server side, we basically used JS basically as needed to fix cross-browser issues, to do widgets that respond to events by the user in the browser. Most of the variables and functions are global. Script tags are dropped wherever they were needed. You would define a new div, leave it empty, and you'd put a script tag right after it. We didn't defer execution, another performance no-no. We didn't have a DOM framework to handle any cross-browser functionality. That framework war happened, and we still hadn't picked one yet. Some words on images. Basically, the UI images that are part of a product would get uploaded individually to production. You could easily forget how to do that when you were deploying, so they would go missing for a little while. Our content photography is extremely hard for us to optimize. We have a lot of pride in our photography. There's a lot of resistance in making them smaller and not featuring them as largely on our pages. We did some experiments with lossless compression. We actually, for color novices, we noticed some colors changing in whatever these tools were. There's a whole department here that does color correction, and the red walls don't appear in their area so that they don't have a little bit of red dilution on their screens to do this color correction. It's basically a manual process to resize these images. We have a lot of them, and in order for them to be fast and have them be smaller, people have to cut them and make sure they don't crop something out of the picture. Because it's manual, it doesn't happen a lot. Other concerns for the business, we have these editorial constraints. Like I mentioned earlier, producers have a need to adjust based on what's happening in the news. So we use this free-form module where they can drop any bit of HTML code. It doesn't even have to be balanced tags, so this can easily mess up our page, but they have the freedom to do that, and we have to be able to handle styles and scripts occurring in them. And ads, of course, they're top-level objects in our DOM. They're not treated in any special way. They bring their own copies of DOM frameworks in. We get older versions of jQuery. We saw an ad that tried to encapsulate prototype, which if you're familiar with how prototype.js works, it modifies built-in objects in the browser. You can't actually contain it in a box, so it didn't really work. Ads animate as soon as they load. We get a lot of painting issues when animations happen while the page is loading. And basically, they are higher in the DOM order as the page is loading than our own logo on the home page. Those ads, you'll see 2 ads, and then you'll see our logo if you look at the source. So just to caveat all of this history, it wasn't really entirely all bad. We do use a CDN. We've had Akamai for a number of years. It's been great. We did turn gzip on in 2007. The bandwidth savings were actually immediate, and there were a lot of really happy people as soon as we did that. But it wasn't on previously, and it's worth mentioning that we did turn it on. So a new wind for our efforts and what we were trying to do starting in 2009 to make the site faster. 2009 was a year we were focusing on tools and libraries. We basically built a new build system for front-end files, and this was our first foray into doing automatic builds. We used to manually untar uncompressed files in production, and we were actually pulling changes from version control as opposed to somebody's home directory. They would arrange the files the way they wanted them to appear. We would package them up, and someone would manually unpackage it. Now it's coming from version control directly. There were semi-stateful rollbacks. There was a rollback mechanism, but you could really only roll back the latest one. If you tried to roll back any before that, you would end up in an unknown state, and that was really bad. But the really exciting bit of it was that there were hooks for build scripts. And we could expand on this process basically dynamically. So we did just that for our CSS. It was the first system to use those new hooks. And we wrote a bunch of proprietary scripts to not only unravel the add import directives to make one concatenated file, we wrote a script to also try and remove some of the white space and the comments. This is all downstream from development work, which is also a really good point. We didn't want our developers to feel that they couldn't comment their work adequately. While we were doing this, we were working on our CSS framework. We took the concepts from our design and we turned them into these base files that can be used across the site. We split code into reusable modules and actually tried to reuse them in a sane way. We aimed to have a single entry point at the top of the page. While we were doing this, we were also trying to lock down our JS development. We introduced a top-level namespace called NYTD, and the module pattern also called the immediately invoked function expression. This is a great way to wrap all your variables in a closure, although thanks to Colt, I'm now afraid of closures. We introduced prototype.js as a DOM library. This one bullet point doesn't really reflect the amount of meetings and discussions and debates and fights we had over this decision, but prototype.js won out in the end. We also tried to write our own proprietary asynchronous JavaScript loader in the days before require.js. Any of these lab.js, any of these loaders, they didn't exist. We tried to write our own. It didn't really work. It became a synchronous JavaScript loader. So we started with our homepage, and there's a number of reasons why. It's published very frequently, so this problem with legacy markup really doesn't become an issue. It gets the most traffic, so it has the potential to save people the most amount of time. It has an isolated implementation. Basically, if something went wrong, nothing would go wrong on other parts of the site, and it's viewed very heavily internally. If something were really bad, it'd get noticed before it got out into production. So in November 2009, we put our CSS optimizations on the homepage. It saved 25 HTTP connections to what are very small CSS files. The first paint occurred a whole second earlier, and the homepage really felt faster, and we were very happy by this. So in 2010, we wanted to continue these efforts. The CSS framework basically rolled out to our section and article pages. Again, we were focusing on these single entry points, but we never optimized them. There were some concerns with these proprietary scripts, and it turns out later when we did an audit that we were right to be concerned. There were references to missing files. There were add import cycles. A would include B, include C, include A. And if you're ever curious about what the browser does to get out of that, I still don't know the answer. And there were syntax errors, that there were styles not getting applied because they were typed improperly. So we decided to build a new JS build system in 2010. We forked the code base. We wanted to create a clean build, and only code that was modular and namespaced would be able to be in this build. Basically, we had these manifests of files that had an at import-like syntax in a JS comment so that they would be inert if the build process failed. We used YUI compressor for minification. We no longer wanted to write our own scripts. This was well supported at the time, so why not? We were focusing on 2 build files, one at the top, one at the bottom. If you're familiar with the best practices, they say that you're supposed to put your JS at the bottom of the page, so why did we have them at the top? If you remember that editors can put JavaScript on the page. If we wanted them to use our frameworks, it had to be there before they could actually run their code. So we put stuff at the top to make sure that that wouldn't break anything. This build process was executed manually, so it didn't see widespread usage. It's basically almost done only on the homepage. And now we have 2 code bases and still no automatic build process. But when we did launch these JS changes to the homepage, it was pretty drastic. We got a 50% speed up, 6 seconds down from 12. We were very excited by that. So 2011 was a bit of a slow year. As you might remember, if you're fans of the New York Times, we introduced digital subscriptions in 2011. So resourcing for this kind of work was really, really hard to come by. Oh, hello. I don't know what I just did. All right. There were efforts to optimize our analytics packaging. We have a lot of analytics packages, and they were kind of doing some really bad stuff. They got aborted mostly because we were afraid to break these actual reports. We wanted to make sure that the business was able to analyze things correctly, so we didn't continue that. So we used a series of code reviews and style guides to make sure that we were enforcing good standards and best practices to keep the status quo. But at the end of 2011, we made the decision. We decided to replace Prototype.js with jQuery site-wide. And as you can imagine, this is really, really hard. We needed both of them to coexist during the transition. We weren't going to rewrite everything and launch a new site on a new framework all at once. So we needed both of them to basically be around while we did this. But in 2012, a group of 5 developers basically set out to try and excise Prototype.js from article pages. And we were making really, really excellent progress. Things were going great, hours and hours of work. And then we found that there were some inline scripts that made references to Prototype.js. And if you remember that we have these static pages with markup that we can't change, we really have no idea what's calling Prototype.js and inline scripts. And so therefore, we're not ever able to remove Prototype.js fully from our site. So now we have 2 frameworks. They both download. They're both still in use. And this actually causes some really strange bugs. In older IE, where you don't have a getElementsByClass name, Prototype.js would add one, and jQuery will detect it and use it. It returns prototype objects, and jQuery says, I have no idea what these are, and bails. So 2012 also marked the end of life for this proprietary build system. We basically migrated to a system that mirrored our entire SVN repositories via Hudson. We wrote a new script to concatenate these CSS imports. We needed feature parity with what we had before, so we had to write something new to make sure that we could handle it for the homepage, which already had it. It does have all these features, although CSS lint is added on the list to catch syntax errors that didn't exist until 2012, I believe. It uses YUI compressor to do minification and also has to be run manually. So again, it's really just limited to the homepage. So finally, I'm going to talk a bit about some efforts in modern times of what we're trying to do to really fix this problem. So we were really gifted a very rare opportunity by the business. In March 2013, the New York Times announced that it was going to introduce a new article redesign. And it's more, for us, it's more than just a new user interface and a new user experience. It's really a technological reboot. We've changed everything about our systems in order to deal with some of these legacy issues that we've had. So the best thing, and I have an exclamation point here, and it really doesn't represent our excitement by this, we have dynamic pages now. We no longer have to deal with an unknown number of permutations. We can actually change our asset URLs on the fly to bypass the cache as soon as we do a deploy. We pushed a lot of the user customization into the client side. We're not doing it on the server, so we can actually cache our pages better on the back end. We introduced HTML5 boilerplate and modernizer to give us a nice starting point for these new pages. So now we have a modern build system using Grunt. It can be run both in our developer sandboxes and in Hudson to prepare a build. And most of these web performance best practices are actually available as Grunt tasks already, which made it really easy to integrate some of this great advice for our code. And we're using RPM packaging for deployments. They have very great rollback support, and they're really easy to use. So for style development, we switched to using Less. Less itself handles concatenation. Minification is supported by YUI compressor through the Grunt task. So this is really easy to get, these 2 wins. Variables and mixins allow us to do some really interesting things in CSS that we had to do with images before. Arrows, buttons, data URIs, and spriting. So earlier this year, I wrote a Grunt task that automates the creation of sprite sheets. I don't really know what the diction is around sprites and sprite sheets, and I don't know what do you call the individual images in a sprite sheet. I have no idea. So I'm making up the terminology. Basically, the task takes in a bunch of images and exports not only the combined sprite sheet, but also a bunch of mixins and less with the background coordinates, which makes it not only really easy to make these combined images, you don't have to maintain them manually. It's really easy for developers to use them in the code. The mixins are named after the image itself, so you just put the image name and you basically get the sprite. And the best part about it is if the coordinates change because we've added a new image, and if it's alphabetical and you added a C, right, all the images shift a little bit, right? All you have to do is rebuild the system, and all the coordinates are updated. Nobody has to go in and actually figure something out and change anything. And we're currently combining about over 100 small images into one. That's 99 saved requests to very small files that we need for our new design. I'm not showing it here. You can check out the marketing page to see what it looks like. Just a heads up. For JavaScript, we switched to require.js. This handles, again, concatenation and minification in the Grunt task, and we also get source maps, which is something we're really excited to use for our development. We no longer need a global namespace. That's why the slide is titled that we're deleting our window.mytd namespace. We get asynchronous loading of JavaScript, and we basically decided to focus on larger build files so that once you've established a connection on mobile, you want to make sure you keep the latency low. That initial handshake can be really high. So we keep these large build files around instead of using a bunch of individual require.js loads. Since we moved a lot of the client customization to the browser, we needed to make sure we could template properly. So we use _JS templates instead of building with the DOM or any HTML strings. And it's way faster to precompile. You're essentially running a JavaScript function, which is optimized in the browser. Grunt can automate this compilation. There's a built-in task to do it. And we turn them into a require.js module that gets included as part of our build process. So we use Backbone to organize everything into modules. They are reusable, and they are shared across applications if we would like them to be. But the real win is that they give us a bunch of inherited functionality. So we can abstract out touch events and analytics or some common element references so that we can we won't have to look them up all the time, and we can get this functionality in everything very easily. We get event delegation, fewer event listeners, so things run a little more smoothly, and the modules communicate with each other using events. So you can publish events, or you can subscribe to another module's events to find out about changes. So this is the big topic. What did we do about ads? We took ads out of the critical path. What we do is on DOM-ready, we write the ad markup into a new iframe. You just take the frame's document and you document.write it into the frame. And what happens is the ad itself calls document.write. You don't lose your whole page. You would just lose the content of the iframe, which is blank to begin with. So we don't care what they do once they're in the frame, once they load. If they decide to bust out of the frame, they can. But we have this notion of trusted ads that aren't framed. And trusted basically means that they specifically don't do things that are bad for page speed. And also, if there's actually a problem, it's very easy for us to get in touch with them and make the change. And this has been really, really effective for us. So this is the results page. I thought it would be great to show you a comparative slide of our waterfalls to show you how really dramatic this is. We're not quite ready to show you that information yet. It's still being built, so we're not quite ready to do that. But just to give you an overview, before starting to render, the page used to download over 60 requests. It's about 10 now, maybe even fewer. Before we're fully loaded, we had to download 200 assets. It's about 70 now. Start render is under 1 second in Chrome, and document complete is under 3 seconds in Chrome. So this is a huge win for us. Before, previously, document complete would be about 9 seconds on our article pages. So to answer Steve's question about is web performance too hard, no and yes. It's really not that hard. The optimization practices are really not that difficult to begin with, and there's excellent tooling that exists to make it really, really, really easy to do. However, there are some unique challenges that I think not just big websites, but companies tend to have their own challenges that people can't solve their problems for them. And not to mention any legacy decisions such as ours, where we have our static pages that was holding us back. We found that we did this negative feedback cycle. We had this poor setup, and we tried to do this proprietary fix to make it better, and we found ourselves slightly worse off than we were before, even though we were getting slightly faster speed. So here's some stuff that we learned, share some advice. It's really worth it to fight to solve these big, difficult problems. They are the 800-pound gorilla in the room for a reason. Fight to solve them. Once they're out of your way, it really opens the path to making this a lot simpler. We live in a world where you don't have to rely on proprietary systems anymore. You might need some because it's your business, so you may need to make sure that you have all your requirements taken care of. But a lot of the tooling exists to make this very simple. I always say that you should count your HTTP connections before you count bytes in every file. Do the big easy wins first. It's really easy to combine files together than it is to figure out what code is old and needs to be removed from your files. And automate everything. As soon as you introduce manual to the equation, it really doesn't get done. So if you can automate everything, it's by far going to pave the road and make it really easy. So that's it. I think I'm running out of time. Thank you very much. I don't think I have time for questions, but I will be around at dinner. So if you want to come find me, and I can talk endlessly about this, so please find me. I will share all of my knowledge.
All right, and so that's one point. You can talk to people at dinner time. We may have time for questions at the end of the night. We'll see. All right, so our next speaker is Adam Grossman from Forecast. Really, if you haven't looked at this, you should look at it. You should pull it up on your browser, maybe right now, and see how it is. One quick question. Is everyone okay on temperature? Raise your hand if you're too warm. Okay, looks good. TimesOpen.
But I want to figure out how to do displays.
Okay.
That works. Let's try that. Oops,
Other
wrong
way. Yeah, drag the menu bar over to the other one. Yeah.
All right.
Play right there. That button right there.
You'll have to excuse me. This is my first time using Keynote.
Right, ready to go?
Yep. All right. Word of warning, I'm getting over a cold, so I'm really hoping that my voice lasts the entire thing, so I'll try to keep this short. And also, full disclosure, right now, I'm a little bit high on the tussin, and it turns out, I just learned this right before coming here, that you're not supposed to mix cold medicine with whiskey. I didn't know that. But that train has sailed, so we're gonna make the best of it. I'm Adam Grossman. I work for a tiny little 2-person company called Dark Sky. We make weather prediction software. We have an iOS app called Dark Sky. We have a weather API for other developers. And we make, more recently, a weather website called Forecast. It's forecast.io. If you want to give us heartburn, you can call it Forecastio. And it looks like this on the desktop. And on mobile, it looks more like this. That's the iPhone version. And we really tried hard to make the mobile experience feel like a native app. So you save it to your home screen. In fact, we require it, and that's a very controversial decision. It lives on your home screen. It's got a little icon. It fits in with all the other apps. And you launch it, and you get something that looks like a native app. And when you slide between views, it's a nice smooth animation. And we've even got a nice smoothly animating radar map. And the reason we did this, and I don't recommend it for all apps, but the reason we did this is because if you want a weather app on your phone, and you've got your phone, you're out, and you want to access the weather, the last thing you want to do, right, is open your web browser, navigate to some weather website, enter your location, and wait for it to load. You just want to launch an app and get the weather. So if we had gone the more traditional route, I think a lot of people just wouldn't use it. So that's the reason why we did it. Now, a lot of ink has been spilt on the topic of mobile web UI performance. And the bigger picture question of, what's the future of mobile? Is it native apps or is it the mobile web? And more recently, the question has been, why are mobile web apps so crummy compared to native apps? And they are, if you take the average mobile web app and you compare it to the average native app, it doesn't perform as well. And of course, there are always exceptions. And if you do some Googling, the general consensus, if there is such a thing on the web, is that web apps are slow because JavaScript is slow. There was a great article, great blog post put out by a guy named Drew Crawford and called Why Mobile Web Apps Are Slow. And he did a comparison. He showed benchmarks of JavaScript versus native code. And he found, of course, that especially on mobile, JavaScript is way slower than native code. And his conclusion is that web apps can't compete with native apps because they're written in JavaScript. And JavaScript has to compete with, on iOS, Objective-C, which is nice and fast. On Android, it's generally Java. Even BlackBerry, presumably Fortran. And all of these are fast, and JavaScript is comparatively much slower, and that's why mobile web apps are slow. This is not true. Web apps are not slow and crummy because JavaScript is slow, and the reason is really simple. Graphical rendering on the web does not happen in JavaScript unless you're doing pixel by pixel graphics on a canvas element. Nothing is being drawn by JavaScript. It's all being drawn by the engine underneath it, which has been heavily optimized. And in fact, on iOS, graphical rendering is not done in Objective-C. It's most of it, at least the heavy lifting, is offloaded onto the GPU. And in fact, you can prove this to yourself with a little thought experiment. Imagine ripping out your GPU, the little chip on your iPhone, and being forced to do everything in Objective-C. You would get a really crummy experience. So really, when it comes to graphical performance, it's not about JavaScript. It's not about Objective-C. So brings us back to the original question. Why are mobile web apps so crummy compared to native apps? And to answer this question, I think I have to stop and give you the 2 rules for how to create performant mobile web apps. There's only 2 rules you need to know, and you only need to know these 2 rules and nothing else. So you might want to grab a pen. The 2 rules for performant mobile web UI. Number 1 is to do stuff that is performant. Number 2, second rule, is avoid stuff that performs poorly. Now, before I continue, a brief anecdotal interlude. Growing up, I played baseball. I was on a Little League team, and I had a Little League coach That's not him. He was much fatter, and that's the wrong sport. And one day, he gathered all of us around and he said, "Kids, I'm going to tell you the key to winning any baseball game." And of course, our ears perked up, and we leaned in. He said, "The key to winning any baseball game is to score more runs than your opponent." Thanks, coach. You're a really bad coach. And it turns out he was a bad coach. We lost most of the games that year. And I know that this rule seems very similar in spirit to my 2 rules for performant mobile web UI. But they're not. They're not the same. And I think there's some interesting things that we can pull from this if we really, really try. The first thing to notice is that on the surface, these 2 rules seem like the same rule, just worded in 2 different ways so I can fill up 2 points on a slide. But really, I think they're different. And one of these rules is much harder to accomplish than the other rule. And if you're going to ask someone who is just starting up in web development which rule was easy and which rule was hard, he would say the hard rule is the first one, doing stuff that performs well, finding the techniques that you need. Because there's a lot of stuff you need to learn, and learning is hard. And you have to learn about CSS transitions and app cache and browser compatibility and all of that, and that's really hard. Meanwhile, rule number 2, avoiding stuff that's easy, that's not doing something, and not doing something is really easy. And you can just try things. And if you look on your phone and they don't perform well, you just don't include it. And so that's really easy. But I think true enlightenment comes from the realization that the situation is reversed. That in actuality, the hard one is to avoid stuff that performs poorly, and the easy one is to do stuff that performs well. I need my water. So, I've been doing web development for a while, doing freelance before started Dark Sky, but I'd never done any big mobile project like Forecast. And I didn't know really where to start. I didn't know what the performance bottlenecks were. So, what I did was I went to Google and I asked Google, "Hey Google, how do I make smooth animations in mobile web apps?" And Google said, "Hey, here's some links you might like to read." And there's a whole bunch of them. And the first thing you learn is that if you're going to make mobile animations that are performant, you should use CSS transitions and transforms because they're hardware accelerated and they're fast. So I went back to Google and I said, "Tell me about CSS transforms and transitions." And it worked even though I spelled transitions wrong. And suddenly, in a weekend, I was able to make my animations fast and performant on my iPhone. So then I went on to the next thing. I asked Google about touch events. And it told me about touch events, how to capture the event when your finger touches the phone. And suddenly my smooth animations were interactive. You can interact with them. And then I got excited and I went on and I asked Google about app cache. It is this thing I'd heard about. I always heard that it was tough and confusing, but you ask Google about it and it gives you the links, the blog posts that you need to know. And the app cache is something that, it tells the browser to cache the app so that next time you go to it, you don't have to pull in all of the HTML and JavaScript. And suddenly, your interactive, smooth animations now loads quickly. And finally, you want to make it into an app that you save to your home screen. So you ask Google, how do I save mobile apps to the home screen? Because that would be really awesome. And it tells you about meta tags that you can include in your page. It's really easy. And when you include those meta tags, they, the Chrome disappears, the back button and what have you. And you now have an app that fills the screen, and you also find about meta tags for specifying icons. So in very little work, in about 2 weekends of Googling, it's not tough. In 2 weekends, you can have, an app that lives on your home screen, has an icon, and when you launch the icon, you get an app in full screen, and it's performant, and it's great, and suddenly the New York Times is asking you to give presentations, and I think that was the body from someone else. That's not my body. So learning the techniques that perform well is actually pretty straightforward. It doesn't take that long, especially if you're already a web developer. And we like to think that web development is difficult, because it's our jobs, it's our livelihoods. But in reality, the hard part is all the stuff that happens behind the scenes, all the people that work on the WebKit team, people at Google and Apple and Mozilla who are making the tools, doing the hard work to give us the handful of tools to make mobile apps that perform well. So this is easy, and I really think that avoiding techniques that perform poorly is the hard part. This is a little bit counterintuitive because introducing crummy performance on the web is really an active endeavor. The default is good performance. So one of my favorite mobile websites is Wikipedia, and this is one of the only content-heavy sites where I actually prefer their mobile site over their desktop site on my phone. And it performs beautifully. I think the most complicated thing on the site is an autocomplete in the search, but they don't try to do anything fancy, and because of that, they get great performance. It scrolls beautifully. When you click on a subheading that's collapsed, it just appears, and no jittery animations, and because there aren't any animations. So really, good performance is the default. And when you come across crummy websites, it's because someone is actively making it crummy, and that's a very perplexing thing. One example is I was reading a blog, and it had a mobile interface, and I was scrolling through it, and vertically, and as you're apt to do because your thumb is on a weird swivel, I couldn't scroll perfectly up and down, and I managed to go a little bit sideways, and all of a sudden this red semicircle appeared, and it had this chunky, animated, kind of bitty, disgusting loading screen. The UI froze up, and then a new blog post loaded. And it was because someone tried to get fancy with a swiping gesture to load up new blog posts, and it failed miserably. And this is someone who was not heeding rule number 2. Another example is on the ESPN site. I just saw this, where you get a main headline, and then you get a one sub-story in a more link. And when you click that more link, it comes up, and you get more articles. And when you do that, it is this chunky, horrible animation that's a few frames a second. And doing this in a way that is smooth takes no extra work than doing it in a way that's not smooth. This is a major website, and they failed to heed rule number 2. There are design examples of this too. Anytime you see content that spills over, or nav that spills over your content, it's someone who's actively incorporated crummy design. My favorite example is this website. You go here, and I kind of exaggerated it by putting it in landscape, but you have browser Chrome on the top and the bottom, and then they've introduced a header and a footer that's always there, fixed positioning. And I don't understand the share links. It's as if you're going to get halfway through the article, and you just can't wait to share it on Twitter. So it's there, and again, so it's not just performance in terms of making smooth animations. It's also the design too. And this is someone actively making the design worse by doing this. The rest of the site looks really nice, but this one aspect. So why do we do it? If it's an active thing, it seems like it should be really easy to avoid. And it seems to be a bigger problem on the mobile web than in native apps. And why is that? I think this rule, avoid stuff that performs poorly, I think the key difference between native apps and mobile web apps is that this rule is really easy to break on the web, and it's really hard to break when you make native apps. So what do I mean by this? On the web, you're given all sorts of ways to do things. And generally, the way that you've learned them when you're just making static content is not the way you should do things when you're trying to make dynamic animations that perform well. So one example is, say you make a static page and you want to position something absolutely. So you give it a CSS position absolute, and you set its top and left attributes, and you put it somewhere. And now say you want to make it dynamic, you want to animate it. I think the first thing we all do is we load up jQuery, and we animate the top and left attributes in jQuery. And when you try it, historically, that has given really poor performance on mobile. You should really be using CSS transitions. Meanwhile, on native apps, and this is especially true in iOS. As far as native apps go, I'm only an iOS developer, but I imagine this is true on Android. Apple makes it really hard to do things that perform poorly. Apple gives you UI kit and core animation, and there's all sorts of juicy things you can do with this, and you can't find anything in there that performs poorly. If you try to break it and try to do these things, it's really hard to do that because Apple has it locked down, and they only give you tools that perform well. And one big example of this is it is possible to make, of course, iOS apps that don't perform well. And the biggest way to do this is to do custom drawing operations. And so in the iOS world, there are things called UI views. And UI views, you can think of them as divs in the HTML world. They're just generic rectangle containers that you can put stuff in. And you can implement an optional method on them called drawRect. It's optional. You usually don't want to use it. But when you implement it, it turns a UI view into essentially a canvas element where you can do canvas drawing to it. And actually, the syntax is very similar to the syntax for canvas drawing, presumably because Canvas was originally developed by Apple. So Apple cares so much about you not using this that they'll actually put this optional method. When you go into Xcode and you create a file, they'll put this method here, they'll comment it out, and in the comment, they tell you not to use it. And I think the only reason they actually put this here is so that they could tell you that it adversely affects performance. And so I think this is the biggest difference between the native world and the web world, is that it's really hard to break this rule. So where do we go from here? How do we avoid making crummy web apps? I think the biggest thing, more so than on native apps, is discipline. We need to take great care that we don't introduce poor performance. Some things to watch out for are, well, the biggest thing to watch out for, and this is something that I fall for all the time, is falling in love with a bad idea. So maybe you have an idea. Presumably, the person who made that blog post with the really awful swiping, he fell in love with the idea of swiping to get back and forth between blog posts. For me, it's been a lot of things. I wanted to implement a thing in Forecast for deleting saved locations where when you click the delete button, the thing jumps up, crinkles up, gets thrown away into a trash bin, and fades out. And this is, it's really seductive to fall in love with an idea. And when you test it, it'll often work because you're testing it in a environment that's not a real-world environment. And it turns out when you actually implement it, when it's actually interacting with other things on the page, sometimes it fails. And if you fall in love with a bad idea, it's sometimes really hard to let it go, and it stays in. And sometimes you don't listen when your friends try to talk you out of it. And they say that idea is no good for you, and that's fine. Experiment, fool around a little bit. We're young, but don't settle down too easily if it turns out that the idea turns out to be no good for you. I don't know why I used this picture of an example of a couple that's no good for each other. They look really happy. And if one of them decides to change their hair before the other. Another thing to avoid is, of course, designer-developer disconnect. And this is tends to be true at larger organizations where you have a designer designing something or a team of designers and they hand it down to developers. And time was, you could design something in Photoshop because websites were static and developers could implement it. And sometimes they had to do disgusting things like chop it up into a grid of images and use tables. But it worked. But now, especially on the mobile web, websites are dynamic, they're animated, and it's really hard to design for that, especially in Photoshop. So designers may have these great ideas for how to do things, how to interact with things, and when it comes time to actually develop them, it doesn't work. And I think that very often developers don't speak up about it, and it stays in there. So I think the way to avoid this is to really, developers take ownership in any design work and any app that you're working on. I don't know any organization where a developer couldn't go back to the designers and even back to management and say, this was a great idea, but it turns out when we actually implement it, it doesn't work. So there needs to be this cyclical process of development. Another thing to avoid is one platform preference. I am an iPhone guy. I love my iPhone. I will never switch to Android. I have a bunch of Android phones, and I never use them. I have a Firefox OS device, and I really want the Firefox OS device to be great, but it's not that great, and so I'm really about iOS, and this is to the severe detriment of Forecast because it works way better on iOS than it does on Android. So this is something to avoid, and this is the lesson I need to learn, but I haven't. I can put it in the slide. The next thing to avoid is what I call test blindness. And when you develop an app, as you progress in development, you're constantly using it, you're constantly interacting with it, you're loading it on your phone, and pretty soon you learn how to avoid interacting with it in a way that breaks it. You know all the little hidden gotchas, and subconsciously you avoid it. And I do this all the time. I'll do something and I'll think it has no bugs, and then I'll hand it to my wife, and the very first thing she does is break it. She'll double tap on things you're not supposed to double tap on. She'll slide when you're not supposed to slide, and it completely falls apart. And so the way I know that I'm falling for test blindness is when I show a new app to someone new on my phone, and instead of handing it to them, I load it up and I show it to them, and I show them how I'm interacting with it. Isn't this a great thing? And I don't hand over my phone. And I've seen other developers do this too when they're working on something, especially when it's in beta. And if you're afraid to hand over your phone, if you try to show people it by you interacting with it, then you're probably succumbing to test blindness. So these are the things to avoid, and there's lots of other things to avoid. But it really boils down to this. The only way that we're going to compete with native apps is through unflinching diligence to keep crumminess out of our apps. You know, native app developers have it easy. They got it by default, but we have to spend every waking minute that we're developing a mobile web app and make sure that that crumminess doesn't get introduced, because once it's there, it's really hard to get rid of it. Thank you. One quick thing. I do have one anecdotal postscript that has nothing to do with the mobile web app UI performance. I had one slide in here where I was going to talk about how web development is so easy that you could teach my grandmother to do it. So here's my grandmother, presumably rocking out in BBEdit, listening to 5x5 podcasts. Actually, this is not my grandmother. I had to do a Google image search for old ladies on a computer, and there's a lot of images of old ladies on computers. But one really strange phenomenon is even more than there are old ladies on computers, there are a bunch of old ladies smoking cigars. I don't understand this phenomenon. It's all over. The web is filled with old ladies smoking cigars. This one's my favorite. It's inexplicable, and this may be the Robitussin talking, but I love that we live in a world where such a thing is possible. Thank you.
Thank you, Adam. Okay, it's time for dinner. Wait. There's a lot of us. There's a small space for getting through to food and drinks. Food is on this side. Drinks are on this side, okay? Consider taking the side you're on to get that thing first. We're going to have to cooperate to get through the food and get everyone through and fed. Also, consider that when you're looking at portions. We have more food, but be considerate of your fellow attendee. We've got a little bit of time. We have like a 40. So we need them back here in, okay, 8:30. So back in your seats at 8:30. You can eat in here. You can eat out on the balcony. Get to it.
2. Mic check 1, 2.
All right, everybody, you can find your seats. We're ready to begin the second part of our show this evening. We've got Colt McCandless from Google here, and he's going to be doing something, if you've never seen it before, it's pretty interesting to watch. He's going to be looking at other people's websites, looking at them through the lens of tooling that's available in Chrome and his expertise as a performance expert, and look at performance issues that are happening and why they're happening. He'll tell you more about that, and we're also going to be looking at some stuff on mobile, so this should be pretty interesting. So without further ado, Colt McCandless, developer advocate at Google.
Very much. We good? Test? Can everybody hear me? Can everyone see how bald I am from where you're sitting? Hands up if you can see your reflection in my head. Anybody? So I have a really tough job tonight. My job is to try to keep you entertained and awake at this time of night after you've been fed and alcoholed. So I'm going to try to do that as best I can. Let me introduce myself really quickly. My name is Colt McCandless. I'm actually the team lead for Chrome Developer Relations Performance. About a year ago in January, we actually identified that the web performance community was good and doing well, but we didn't have someone focused on bringing the message to people constantly. As talked about in the previous talks tonight, it's really easy to do dumb, slow things on the web, and one of the first things we need to do with that is fix it with education. So we kind of defined from the beginning that after looking at all the education and looking everything out there, there's really three pillars of web performance, okay? Up until now, the web as a whole has really only focused on one of them. All you've heard from most performance experts is how fast does your website load, right? We've all seen the studies that show that 1 millisecond of time actually related to $10 million of lost revenue for site X, Y, and Z. And they only really talk about network. But in the modern age of web applications, we often tend to neglect the other two pillars of web performance, rendering and compute. A great part of the forecast on it? No. I wanted to see. He was listening. That was good. I wanted to test. See, I got to keep you awake too. One of the great parts of the forecast talk, I believed, was when he really said, we have to actually solve this problem of rendering because it doesn't happen for free. I think the existence of the previous type of web, where CSS animations weren't something you even had availability to, allowed us to do really stupid things, and the browser kept us really fast. But now, because we kind of contend our own yard, we're running into some problems there. So when you think about performance, you should know that network, render, and compute, you can have problems in all three of these. And much like Jake said earlier, right, like a huge problem in one of these portions can actually cloud out issues that are happening in the other two. So as you're going through your process of finding performance issues in your website, you need to make sure that you're evaluating all three of these with the right tools at the right time. And what I'm going to do tonight is I'm going to try to walk you through some of the sites that you've submitted, and hopefully bruise your ego a little bit. No offense, it's what we all have to do. Quite frankly, I think one of the big things we've been trying to do with the web performance movement over the past year is actually bruise a lot of egos in the web. Because we're all programmers, we're all smart. We're too smart, quite frankly, and we got to be taken down a peg, right? Because we all know in here, everyone in here, think about your coworkers, right? And think about what really motivates them. 99% of the time, if you can bruise their ego or challenge them or tell them they're not good enough or the problem's too hard, that's what actually gets them to move, right? Yeah. Okay, maybe. If you got Yankees money, I guess so. So this is the loop, right? So this is what you should all be thinking of. Now, I've got about 10 years of game development background under my belt. I'm a C++ programmer at heart, and I'm trying to apply a lot of the lessons we use in game development to web development, because in reality, we're both dealing with real-time media interfaces, right? So when you guys say, how fast can something load off an internet site, I'm thinking, how fast can that stuff be streamed off a DVD, right? It's the same problem we've had just 10 years later, right? So when you're doing your performance, the main thing that you have to do is follow these three steps. The first thing is you need to gather information, right? You go open up Chrome DevTools, you open up webpagetest.org. This gives you information about what is going on in your page. From that, you actually need insight, because really, what's a whole sheet of floating point numbers mean to you? Nothing, right? You need to know what those floating point numbers mean, and your tooling system needs to be able to infer what those floating point numbers mean. And then once you have that insight, you need to be able to actually plan an action. You have this data, you have to then go to your manager and justify, please, let me spend 2 weeks fixing 7 milliseconds of load time from our website because it matters. And then you need to be able to repeat this constantly. You need continuous integration tools. You need the ability to actually track down whose check-in broke the build. quick show of hands, how many of you in here actually have some continuous integration for performance in your suite right now? 1, 2, 3, 4, 5. Well, is that, wait, were you just showing me your Pepsi can? Okay. I mean, it's a cool can. That's, bravo. So maybe 4, maybe 5 out of an entire room. I've asked this question to probably about 3,000 developers this week while I've been in New York and meeting and giving talks, and the total number of people is close to about 15, with the 5 in this room. This shows that there's a huge problem in the web community, is that we're not actually testing for performance and giving it the gravitas that we are our features and our CSS and those pretty little bubbly items everywhere else on our pages. And this is why we actually moved forward with trying to build a better community about this. So for you in the audience, this is the only slide I want you to take away from today. Burn this into your retina, tweet it, blog it, like get a tattoo of it. If you get a tattoo, tweet it to me and I'll send you some swag. Please don't get a tattoo. Anything I say is not representative of any organization or Google or the lawyers that are affiliated with me. All comments are my own. Please do not get a tattoo. First off, if you're doing performance, go to html5rocks.com. There's a landing page. It's called Performance. You click on the button. I'm actually the guy that maintains that page. Right? If you start there, it's going to walk you through the 3 pillars of web performance. You're going to be able to go step by step on how to find and address the largest problems on each one of these 3 pillars. Next is you need to be following and using the perf matters hashtag. We actually started this hashtag just earlier this year, and we wanted to use web perf. We really did. We wanted to use that hashtag. It was out there, but we didn't feel like it bruised enough egos. We wanted perf matters to be this name, this brand, this answer to a question. Right? And what we saw was very quickly people started hosting links to their friends' websites and be like, yo, dude, why does it take 15 seconds to load your site? Perf matters. Right? We wanted it to be something you could take to your manager and say, hey, it takes 15 seconds for our site to load on mobile. Perf matters. We want this to be a badge. We are all egotistical programmers. Wear the badge. Right? Own the sticker. Make it a part of your culture. Make it a part of your environment. That's what we want. We want attitude in that. That's why you should follow that hashtag. Finally, check out the G+ web performance community. If you're in Google+, it's a cool place. A lot of cool people hang out there. Some of them are bald. Some of them post content. I'm not saying who. But you need to follow that because really, if you combine Perf Matters with the Google+ web performance communities and the articles coming through HTML5 Rocks, you're actually going to find an overflow of information. I bet most of you in here haven't actually dived into, here, we'll do this. Put your hand up if you've read more than 5 articles about performance. Okay, we're going to keep your hands up, More than 10 articles. Okay, let's ramp this exponentially. 20. 28. Let's go 40 articles on performance. Okay. For those of you who have had your hands up, of those 40 articles, how many of those things did you implement? Maybe 5, 6, 20? No fair if you actually did a talk earlier tonight. I'm not taking your input. So the point that we're getting at, though, is that for those of you who haven't been reading a lot of this content, this is actually going to be an overflow of information. Hopefully you can find it, you can guide it, you can move through it. What's the next one? Yeah. So what I'm going to do now is, with the rest of the time, Pete, how much time do we have? 40, 60? As much as I want. Keep talking until people fall asleep. Good, I can do that. So what we're going to do is, I'm actually only going to load these websites on mobile. Quite frankly, I ran through these earlier today, and most of your sites actually fell over dead on mobile. There were some interesting use cases on desktop, but quite frankly, desktop's dead. If you're not making your site mobile and friendly and fast there, you're doing it wrong. Period. Mobile is all that matters right now. Hashtag perf matters. You can tweet that. I'll give you a second. No, go ahead. It's OK. Hashtag perf matters mobile. OK. So we're going to take a look at a couple of these really quick. And I'm going to try to organize these in terms of discussion and pointing out a couple things. So if we don't get to all of them, I apologize. Please feel free to email me later and curse at me. Or do it on social media. That's always fun, too. But what I've got here is a little setup. And you can actually see my little phone, so I can click on some stuff. And what I'm using over here is the Chrome Developer Tools ADB extension. OK, so this is a fantastic little who's using this? Anyone using this? Wait, no fair if you're hosting the event, dude. God, you guys are cheating. So this is a fantastic Chrome extension. You go to the Chrome web store. You can actually download and install this extension. Basically, what it allows you to do is interface with the Android developer tools very easily and quickly. So I can actually click on this and go View Inspection Targets. And you'll actually see that it loads and shows me this Galaxy Nexus phone that's actually plugged in right here, right? And I can actually click, well, I'll close this so you can actually see what this looks like. I can click the Inspect button, OK? And what this Inspect button shows is it actually shows me what's on my phone right now. Okay, so this is one of the sites. I'll get to it in a little bit deeper here in a minute. But this is actually what's on the phone. You can see it's moving, it's scrolling, it's doing stuff. We go over here and you can actually see the network. So if I hit reload on my phone, you can actually see the network request coming through. Right? This is not the desktop site. This is actually a mobile site. This is really good because I'm actually testing on the device that my users are using. Oh, wow, great comment. Hashtag perf matters. One of you will tweet it tonight. It will happen. I'll keep drilling it into you. But the cool thing is you can actually see what's going on here. And notice for this particular website that it's actually not done loading yet, right? Like you can still see the bar moving on the side over there. And the funny thing is if you load this site in desktop, you don't see that same problem, right? So obviously there's an issue on the mobile that is not showing up on the desktop. Again, we need to make sure that we're testing things properly. But the cool thing is we can actually see all of the same events, use the dev tools in the same way, minus everything crashing because of memory issues, which might happen tonight. I apologize for the live feed. But we can actually go through here and just record memory and see what's going on in memory, right? And so let me show you over here. I can go through and actually scroll and go back and actually see how memory is adjusting based on this stuff. So if you haven't adopted this Chrome ADB extension into your tooling and your testing, you need to definitely do this. Definitely get this in your stuff. Because, I mean, no other tool allows you this sort of integration, right? And Chrome DevTools are already top of the line. It should be part of it. So anyhow, enough of me babbling. So let's start with one of the first sites here. Come on, clicky, clicky. There's a native app for you. Slow and loading. Right, Forecastio? Oh, I'll get it right. Sorry. So we're going to try this first one here, allout.org. This was submitted. Someone in the room submitted this. I don't know who it is. Doesn't matter. But we're going to take a look at your site, and hopefully we're going to make you upset. So this is loading. I'm going to show you what the page looks like first. So first off, we all just watched it load. This is on a 4G connection. I'm not on the local Wi-Fi, right? We can see that this is not a mobile site, right? I mean, I shouldn't have to scroll. Oh, I can zoom. Yay, right? But kind of most of the site is actually eclipsed, right? We've got some sort of spinner here at the top. It's a marquee movement. We've got some other items down here on the bottom. Some stuff's going on. So let's take a look at what that looks like in Chrome DevTools. Right? So I can go here, click Inspect. Again, native applications, they're slow. So let's go to the Network tab, and I want to take a look at how this thing loads. Okay? So I'm going to hit Reload again, and we're going to watch all the assets come through. And notice here on the bottom here, you can see 6 requests, 12 requests. I'll keep scrolling down to the bottom so you can kind of see that. 7 seconds worth of load time before it's actually loaded. So this down here on the bottom tells us that it took about 6 seconds before content complete was actually kind of issued, right, before the page load event occurred, and 7.9 seconds total. 8K actually came, oh, no, we're still not done. 9K came through, pardon me. And so 34 requests. We can actually see the health of this object and the health of the site. Now 34 requests, that's actually nothing. 9K, that's a drop in the bucket. The Robitussin laced grandmother picture from earlier could easily load 9K very quickly. What's important here though, and I want to show you this, is when we go up here and actually sort by size, we actually get a different sort of sense of the content that's being sent around, right? So we can see, no, let me not do that. There we go. So we can actually see the images loaded. We can actually see that most of the large assets here, 6.4 kb, 512 bytes. We can see that the large images here, this is actually interesting to me. So this is a 1024 by 576. It's 213K. Quick round of applause. Who thinks that's too large for a mobile site? Yeah. Okay, here's another one. Here's 109K, a little bit better. Same resolution though. Anyone notice that? Same resolution, half the size. Now, if anyone in here has another round of applause. Who's written a JPEG compressor? One guy, 2 guys, 3 guys. All right, we'll get some beers later and we'll talk about DCT coefficients. I've had this really cool idea that you can actually, you know what, never mind. So notice though that this image actually has a lot more data to it, right? There's a lot more edges, there's a lot more noise to the image, yet it's smaller than this one here, right? This is actually mostly pink. There's no reason that the image with more detail should be less size than the one with less detail in it, right? What this tells me, I know nothing about these developers, I know nothing about the site, but this tells me that they're not actually exporting this particular image with the right compression settings. I like doing these polls because it's late and I need you all entertained. So how many of you actually just export your images at some constant format? Like when you do an export from a JPEG, it's like on 12 or 80, depending on what you're doing. So no, everyone else hand optimizes exactly your exact perfect PSNR relationship for your JPEG. Yes? Is that what I'm hearing? Because I saw like 3 hands. So either you're all lying to each other or you have no idea the way that your images are. Okay, round of applause for no idea the compression quality. Okay, fantastic. Okay, so seeing this site actually tells us that this is a systemic problem. And again, the 3,000 developers I've talked to over the past week all see this problem. And a couple of the other websites I'm going to load tonight, you're going to see this show up very prevalently. That in general, we as a web community do a horrible, horrible job of optimizing images for quality against size. Now, in reality, this isn't something that's that difficult. Most of us consider a single-way pipe. Right? We have artists or designers that are working in a vacuum, right? They're trying to optimize for the visual quality of the image. Meanwhile, there's bald engineers in a corner somewhere going, why is my site slow? Right? And there's this constant back and forth between these two camps about size of images versus quality of images and load times and all this stuff. Let me give you a little word of advice. If any of you are able to implement something like this, it's very simple to spin up an Amazon EC2 instance, or even do this at your desk, and actually run a compressor, a command line compressor like libjpeg or JPEG Turbo. By the way, JPEG Turbo is the actual codec that we use inside of Chrome for JPEGs. And actually compress it at various quality settings and test the PSNR of the images. PSNR, for those of you who don't know, is peak signal to noise ratio. This is actually a measurement of the amount of noise and error that's introduced to an image. It's the blockiness that actually comes from the compression format. We actually have a standardization process. We call it PSNR, and that's how we compare image compressors to each other. So you can actually take your image, compress it at level 90, see what the PSNR is. Compress it at 80, see what the PSNR is. 70, 60, 50, 40, 30. If you get below 30, you've gone too far. Just stop at 30, right? But the cool thing about this is that you can actually run 10,000, 20,000, 30,000 images through this process, and for each one find the exact right compression value to give you a PSNR of around 38 to 45. Right? So you're not actually just exporting to a single compression number, a slider that your artists have no idea what it does. You can actually programmatically find this value by implementing a simple iterative process against the command line compressor. That's kind of a cool. Round of applause for cool. I saw some of you begrudgingly go, that's not cool. Let's save the questions for the end, if that's okay. Because otherwise I'm going to stare at Putin, and he kind of scares me. So let's take a look at some other things here. So I want to go over timeline. So that was load time. Everyone knows the network stuff. If you're not using webpagetest.org or mod PageSpeed or PageSpeed Insights and all that stuff, you need to be using all that. So let's just take a look at what this site's doing while I'm doing nothing. So now I haven't touched the site, to be clear. My phone almost actually went locked because I haven't touched it. I'm still not touching it, but I want you to notice what the memory is doing on the top. Now, I'm a C++ game developer. Right? To me, the only thing that matters for performance is follow the memory. Right? I actually gave a talk at Velocity yesterday where I, in a very heretic fashion, suggested that web developers were really bad developers because we're not controlling our memory. We're actually letting JavaScript do it for us. And because of this, we have no idea what's going on under the hood. Right? How many of you know what your heap size is? How many of you care? That's another question. I like that. I like your outfit. Is that like a cummerbund? Like, what is that? Is that like a real? Yeah, I like that. That's cool. I'm gonna have to get me one of those. Perf matters. I gotta get me one of those. So again, I've touched nothing, but notice this here on the top. I don't know if you guys can see it. It's allocating between 7.5 megs and 9 megs. I'm touching nothing. Nothing's occurring on the screen. Yet 2 megabytes of data are being allocated and cleared in this environment. Now I can actually figure out what's going on with this. If I stop my recording, too much information. Let me just do a quick record real quick so I can clear all that. So we can see something on the timeline here. So it looks like, first off, they've got like 2 different timers firing, right? So we've got widgets.js and chartbeat. Chartbeat, I'm guessing, is like an analytics thing. I see this on a bunch of sites you guys gave me. And then widgets seems like their thing. So I'm guessing this is that marquee scroll at the top, right? They've got some timer that's actually moving those images around. What I don't like, pardon? For widgets.js? Oh, cool. Oh, nice. Widgets.js. Twitter. Oh, cool. So Twitter's actually screwing this page up. Go Twitter. Is anyone in from Twitter? Boo, Twitter. So what we see down here, though, is we see recalculate and paint and whatnot. For our memory, this view doesn't actually tell us what's being allocated. I mean, we can see where the events are occurring and whatnot. I can actually mouse over the GCs when they actually happen. More importantly, though, I can actually go over here to the profiles page because I don't like seeing that kind of memory. And I can actually do a record of heap allocations, right? So I can just hit start and let this thing run. And basically, what you're seeing here is on this top, you're kind of seeing timeline view plus memory profiling at the same time. In the top, any of these blue lines is when memory allocations occur. Now, when you see a gray line, what the gray line means is that memory has been freed by a garbage collection process somewhere. So you can actually see a new set that just happened, and some of the gray lines happened. But these blues tend to kind of pop up in a very regular fashion. Now, in this, I can actually go through here and change the size of my window and actually see exactly what was allocated. So in this single event, at about 8 seconds in my capture, about 3K worth of data was allocated. And we can see a similar pattern over here, right? I can highlight this window, and we see another about almost 3K, right? And over here, a similar window is about 3K plus a lot of extra change there that hasn't been freed up yet. But let me focus on this guy really quick. So here I can actually see that 3K came from compiled code. So somewhere in the system, de-optimization code came from. Now, for those of you who are not versed in fast path and slow path JavaScript, effectively what this little block of data you're seeing here, see that de-optimization data? The way that V8 and most modern JavaScript VMs work is they will actually try to optimize your code on your behalf. Because, I mean, come on, you're a stupid programmer. You don't know how to write code. Obviously, the VM knows better than you because it's a machine and it's fast and it's smart. So what it'll actually do is take a code path that you've written and it'll actually optimize it. It'll manage the memory, it'll make some fast path optimizations, and it'll put it out there and start running it. Well, the problem is that it does this with some assumptions about the state of the environment that it's in. And it'll do this, and oftentimes it'll break. And it'll go, whoa, we actually caused an exception somewhere in the stack due to our optimization because we're just a stupid robot and we actually don't know what we're doing either. When this happens, basically Chrome has to create this new block of code that's parallel to the block of code you had, delete your block of code, put your new block of code in the stack, and have it execute. When that de-optimization occurs, because the optimization failed, it has to take your old block of code, put it back in, and delete the block of code that it just created. So there are specific code paths that generally cause this to happen. Closures are one of them. How many of you are using closures in your timers? Don't applaud. I don't want you to applaud that. Okay? Closures are one of these things. If you actually have a closure running, so it's very common for people to do set interval closure, comma 1000, right? That closure in that set interval is actually causing these sorts of memory leaks to occur, right? It's a de-optimization path that V8 can't optimize around. And so basically every single time you're doing this, you're running into this situation. So let's take a look at something else really quick. So I want to go over here and show you what I'm seeing on the screen. Now, I've turned on a couple modes on the developer tools. So first off, you'll see this beautiful little, you can't see it too well. I wonder if I can tilt my phone just a little bit. You can see up at the top that I actually have a little graph showing me frame rate, as well as how much GPU memory is being used, right? So this is actually, for a quick show of hands, who understands how a web page is painted? It's like the same guys that wrote JPEG compilers. OK, so for everyone else, let me do this really quick. How your page is rasterized is a delicate ballet. Really, it's more like boxing. It's basically two people smashing each other's faces in for about 6 milliseconds a frame. Effectively, what happens is Chrome will take your web page and it will dice it up. It'll create square regions of 256 by 256 tiles. For each one of these tiles, it'll actually spin up a thread and actually rasterize all of the pixels in that tile, all of the WebKit, well, blink now, sorry, I got to get my terminology right, all of the page elements, and actually composite that to a CPU chunk of memory, 32 bits per pixel, 256 by 256 tile. And it'll rasterize all that data in there. Once that data is rasterized, it'll then upload it to the GPU. When you scroll a page, the GPU is actually the thing that's moving your page. Now, for those of you, some of you in here are young, much younger than me. You may not know this. But back before Quake 3 was hardware accelerated, we had something called software rasterization. Yeah? Software rasterization? Heretic, Doom, Quake? Anybody? Any other professional gamers in the house? Yeah. So back then we used a term called software rasterization. This was generally OK, but once we invented GPUs, GPUs are basically hardware rasterization. They're built to take pixels and put them on the screen. They're dedicated silicon for this, right? But Chrome is actually still using software rasterization to paint the pixels on the screen. This means that this is a slow path. This also means that every one of you right now should be really, really scared. Because how many of you have actually tested whether or not those rounded corners and drop shadows affect your render time? They do, actually, quite frankly. If you go to HTML5 Rocks, I actually did a study on this. Haha. I'm sorry, that was a leading question. That was mean. I knew that you didn't know that answer. But basically, what happens is your CSS effects actually cause right? It has to be software rasterized, which means we have to actually go and draw rounded rectangles and then actually add a drop shadow to the side of it, right? And this actually takes more time. In fact, if you have those two combinations of things together, it actually takes 4x as long as each one of them individually, which means that there's combinations of CSS properties that hurt your rendering performance more than others. Hopefully all of you are going, dear God, I have to test this right now, okay? And how you can test this is you can actually see up here in this GPU, this frame rate meter, is that as you're scrolling, you can actually see the milliseconds taken to render that part of your page. Now, what you're also seeing here is notice this big red box that keeps popping up. This is actually a mode in Chrome DevTools. Let me show you this. And I know I'm spending more time on this site. As we go to the other sites, you actually see this stuff play out. But I need to kind of test the groundwork here. Is that in or left? Left. Oh, wow. OK. I'll keep working. So anyhow, I have show paint rectangles on. Basically what this does is when I turn this on, it's going to show a red rectangle for every part of the page that actually gets repainted. So this actually tells me what part of the page is being re-rasterized, which is really cool to know, because I'm pretty sure all of you will look at your site and find that you've got some little square icon like this, but for some reason it's rasterizing like a 6x size window of that all has to be reprocessed on the CPU. This slows down your page. It creates jank. I hate that word. Hitching, by the way. Hitching is the right term. Every other medium, video games, AV, movies, it's called hitching. Can we all agree to use hitching? No? I'll get hitchfree.org later. Anyhow, so let me move on to the next site, because I want to make sure that we talk about some more stuff. But basically, you can see that on this site, there's a couple things. First off, they're sending 2 large images to a mobile device. They don't have a mobile view. They don't have a mindset of a viewport for these mobile environments. Plus, it seems like their marquee is actually rendering and updating different parts of the page at different frequencies. They're allocating about a meg of memory per minute or so that when no one's touching anything. So if this is your site, fix those things. Because you need to, and also your load time is pretty harsh too. So let's do this next one. So this next one should be pretty quick. I just want to highlight something really poignant here. So I'm going to close this. Which view are you on? OK. So let's show you. So this is dosomething.org. Cool little website. It kind of just encourages everyone to do something interesting and like small little, small butterfly wings change the course of tides in Africa and all that stuff. But we see it's a pretty simple website, right? Just kind of a little strata of images and whatnot. When we go over here to Chrome DevTools, let's inspect this information here. And I'm going to put this back on the network tab, and we're going to go ahead and reload this. So we can actually see that the page loaded pretty quickly. We got a lot of information really quick, about 2.9 seconds. So this is a lot better than the previous website, right? We're right around that 3-second load time, right? And this is on my 4G. I'm not on the wireless. So that's pretty good. 10K transferred. Oh, OK, that's all right. 21 requests. Not that bad at all. So let's again sort by size. Let's see if anything's coming up here. I got a couple not founds. That's not necessarily a good idea. A couple images here. So this is interesting. Again, another 106K image that's being delivered to a mobile screen that obviously does not need 106K. That one's a little bit better. Well, not better. I mean, that's a very depressing image. I didn't mean that was. Again, my opinions are my own and not that of any organization or secret service that I'm influenced with. So we can actually see some of these images may be a little bit larger than others. But for the most part, this is actually nice. What happened here? Did I? This technology, isn't it great? So we can actually see, though, that this page is actually a pretty good example of what to do on a website, right? If you load this on the desktop, what you'll actually see is that there's larger versions of these images. They're tiled differently with a different layout. There's a different scheme. But in the mobile version, they really only have 1 or 2 images that are probably too large for the mobile device. But in the most part, this actually scrolls pretty quickly, right? I know you can't see it up in the top here, but this is actually about 3 milliseconds to 5 milliseconds to actually draw the part of the page. And you can actually see that as I'm scrolling, notice that there's no red tiles, right? You don't see those big red flashes. What that means is that this entire page has actually been rasterized on the CPU and uploaded to the GPU, and it's been cached in the GPU. And so as you're scrolling up and down, the CPU doesn't have to do any work, right? So this is what you want. You want no red blocks going on your page. All right, so let's do another site here really quick, because now I'm freaking out that I only got 30 minutes. Yes! Oh, we're going all night. Let's just open up every website. OK, so this is the one we saw a little bit earlier. Sorry, I don't know if my antics distracted you all. Let's reload this again. Let's see how the load time is. So notice on the top here that it's about halfway. So this page hasn't unloaded yet. Let's just be clear about what we're looking at. This is an instant load. This is now we've actually gotten to the loading part. If this is your website, I'm sorry. Hopefully you understand there's work that needs to do. It might be. Let's find out. So again, over here, let's go to inspect. I wonder if I can just catch this midstream, if it'll just tell me what that image is. Or do I have to hit reload? It's still loading. OK, here. I'll hit reload. See what goes on here. Oh, web fonts. OK, we'll take a look at that in a second. OK, so I hit reload. This is waiting to reload. So obviously, there's already some problems with this site. Hopefully, someone in here is going like, please stop clicking buttons. Please take my website off of your screen, you angry bald man. OK, let's see how this is going here. So you can't see the screen. It's still loading. The fonts just now appeared. Let's take a look at what's going on here and see whether or not we can discuss some of these items. So let's sort by size here. This is something I want to let everybody know, because this is the first thing I want to point out on this site. This is a WAF file. It's a web font. Round of applause if you're using web fonts in your site. Good. Please stop. Please stop. This is a, I don't know if you saw this. Yeah, web fonts look great. They're awesome. This is 38K for that web font. And unfortunately, like some of these have been cached, right? So you can't actually see the true size of a lot of these. But there's actually like 5 or 6 web fonts on this page. So you guys are kind of getting a bum deal. You're not seeing how horrible this is. But basically, here's what happens is, when you've got 5 web fonts, each one can be somewhere between the range of 40K and like 90K for a font. That font is required before text can actually be drawn to your screen. Okay, so pop quiz. What happens if you're ready to draw text, but your CSS is down, and your JavaScript is down, and your images are down, but your WAF isn't down yet? Good answer. I don't know. No one said anything. Good answer. Nothing. Nothing happens. Chrome will do nothing. Chrome will block. Chrome will wait. Chrome will wait for every single one of your WAFs to come down before a single character of text is drawn on your screen. Jake Archibald says I'm dumb. If that single WAF is visible, it'll render that one. Now, Firefox will do it a little bit differently. Basically, what it'll do is it'll wait 3 seconds, right, Jake? Yeah. It'll wait 3 seconds. Maybe you should continue. Have an awkward mic moment. You know? Basically, what'll happen with Firefox is it'll start the request for the WAF. If it hasn't been downloaded in 3 seconds, it'll actually keep allowing that to display or to download, but it'll actually display the font with a default. Like it'll just see Arial. So if you're actually seeing this on Firefox, you'll see like 3 seconds of nothing, and then you'll see Arial, and then when the font comes in, you'll see it pop to whatever the font's supposed to be. And so you see this flicker. I see it. You see it a lot on mobile, right? Because these mobile devices are actually 6x slower in hardware, just across the board, probably for at least another 2 years, depending on which hardware manufacturer you're trending, than what you're seeing on the desktop. So not only is it slower to download these things, but these WAFs are actually very complex spline paths that have to be interpreted by these underpowered ARM chips as well. Anyone in here written a software rasterizer? Cool. Spline paths are slow. Anyhow, WAFs are bad. And you should feel bad if you're using them in your websites right now. Now, things are being happened that are trying to optimize this, right? I know that there's people talking about different ways to compress WAFs and different ways to use these type of fonts in different ways. But please note that if you have them as part of your site, you should feel bad. Now, let me see if can I like shift reload this? I don't know. I can't get the data from cache. But we also see in here a couple of these things, and I can't show you this, but these images are actually a little bit larger than they should be as well. These are OK. Is that Willie Nelson? I don't know. Again, there's another WAF. This PNG, where was this header on that? This one's a WebP. Oh, fantastic. So this guy was actually using a WebP. Interesting. I don't know what that's doing. That was the accept header, yeah. So at least a WebP did come down. However, we see that, let's go down here. Again, 124K. So again, you guys are getting the bad rap because I'm not doing a cached fresh reload on this. But basically, this site is it's actually passing like full megabyte, 2 megabyte images down. It's got the WAFs in the direct path to rendering, and so that's going to take a long time before text will show up. In fact, the image will try to progressively load in before all the text does, and this will annoy your users a lot more. So let's try to avoid that. All right, let's try another website here really quick. So let me go over to this. Is anyone sad yet about the state of things? Is anyone going like, wow, I wonder how my site does under this type of scrutiny? If so, then yay, I'm doing my job. I can get paid this week. Cool, that was actually pretty quick. That actually wasn't that bad, right? Let me do that again. All right. Yeah, that actually wasn't that bad. Here, let me see if I can hard. Load. Good, cool. Okay, so this might be a good site. Let's take a look at this one. So we'll hit inspect again. We'll load it up. Let's see here. Scrolling actually seems pretty smooth on this site, right? Doesn't seem that bad. We can move stuff around pretty easily. Let's take a look at the network tab. Let's hit reload again. Again, unfortunately, all of this stuff is coming from the cache now. I should use my other tablet. .com CSS, not that bad. 22K CSS, 27K CSS, 200K. I don't like this 192K JPEG. That's only 920 by 300. Notice this. So this is 192K for an image that is a quarter of the size of Putin. Quick show of hands. Who knows what that means? Yeah, not optimizing your JPEGs. I think there's actually some other bad examples here. Here's another one, 240K. Oh, 240K, 920 by 300. Does anyone off the back of your hand know what this is if it were a raw image size? So it's 920 times 300 times 32 bits per, or 24 bits per pixel. Nah, get back to me. Jake will give you some swag. Oh, there's a Facebook icon. Only 9K. Yay. That's, well, okay, that's 100 by 100 is 9K. That seems a little bit excessive, right? That seems like there's actually some bloat going on there. I wonder if there's like a negative JPEG encoder. Make it larger. By the way, if any of you are going to be in San Francisco next week or have a chance, or have the internet, I think, definitely tune into my talk I'm giving on compression on the web. And hopefully if you've seen my talk yesterday about being scared of closures, if you see my talk next week on compression on the web, hopefully compression will scare you after that, and you'll trudge toward that monster with a weary eye. But anyhow, 100K pixels, 3.9K in size. So that actually seems a little bit excessive there too. Here's again some, those are the same images. Here's another one. These are really large, 180K being sent to my mobile device. Now the reason this loaded a little fast, this is a bias because I've been testing these things all day and this is coming from cache. So you're not really feeling as much pain as you should be. Oh, beautiful. All right, Jake Archibald for the win. Here, let's hit reload now. There we go. Oh, yeah. Oh, feel it. Feel it. So awkward right now. It kind of should be, yeah. Oh, so. No one's hiding their face right now, so maybe the guy who put this site in isn't here, or you've got a great poker face. I will not bet money against you. Okay, so. And then they shrank, right? So, oh, great. That's actually a great point. I'll bring this up really quick too. How many of you have responsive websites? Okay, you're doing it wrong. Let me ask that in a better way. How many of your responsive websites will actually resize the image that you've been given? Oh, Jake.
What do you do about resizing?
You got a CSS resize. You're changing the properties of it. If it comes down as 1024 pixels by 1024 pixels, and you display it as 900 pixels by 900 pixels or something like that. Anybody resizing? You're telling me every single one of you gives exactly the right pixel ratio for every single device that loads your website. Is that what I'm hearing? All right, that guy's hiding his face, so I know he's doing it wrong. At least, you know what? At least you're honest, brother. I got some swag for you after this. So here's something a lot of you don't know. Decoding a JPEG or a PNG or a WebP file actually takes time from your CPU. And in fact, you know how I was talking about those tiles getting rasterized? What happens is before a tile can be rasterized, Chrome actually has to go decompress all of the images that are in that tile. Now, when that tile is evicted from the cache, we're going to have to repaint it again sometime later. Well, lo and behold, there's actually a texture decompression cache as well. So there's a chance, very high chance on mobile devices, that we'll actually decompress a JPEG file, right? And then have to resize the uncompressed version of it, right? So you're actually getting full 32-bit pixels actually being resized from 1024 to 512. And then the next time you have to render that image, you have to decompress it and resize it again. Right? So if an image is split between two tiles, you can run into a very awkward situation where you have to decode and resize that image for each tile that it's split in. So if you're resizing your images dynamically right now, this could be a problem for your site. Hopefully some of you...
Should we not do dynamic websites?
Save the questions for the end. I said it to that guy, I got to say it to you too. Was that because I called you Forecastio? Okay, that's all right. Much love, brother. Oh, whoa, sorry. Anyhow, so I think we kind of see that this website has some issues, and most of it is on the network tab. Let me go ahead and turn on continuous show paint rectangles as well, because I want to show this off too. So see that red rectangle? So you can kind of see this little one. Let me show it on the screen here. You can see this little pop it up, but watch this red rectangle happen full screen. Did you see that? See that again? Boom, boom, boom. I see this almost on every single site on this list. Basically, they've got a marquee on top, and that marquee, for some reason, is actually invalidating the entire page below it as well. So the actual div that's expanding this thing, that's getting repainted, is touching every single pixel on the page, right? Which means that even sitting here doing nothing, where actually the CPU is just sitting here spinning and spinning and spinning and spinning and working and working. And that's actually going to make scrolling not as smooth as possible. And you can't see it. I can feel it a little bit here. This is actually a pretty janky website. Up at the top, it says that our average frame rate right now is about 18 frames a second, 17 frames a second. Right? I can actually really feel this on mobile. Now I have 30 minutes. Yes. 15 minutes of filler. So obviously this is a problem. And because when I see something dynamic like this, I generally think that memory is going wonky as well. So let's go ahead and do a timeline and hit record again. Let's see what's going on. We've seen this before, right? Same pattern we saw with the other site. We see just kind of memory just being allocated and allocated and allocated and allocated. Let's hit stop and see if we can drill in and see what the culprit is. Again, I know nothing of these websites. I know nothing of, I'm just a primitive C++ developer. Your web development scares and confuses me. So let's go to profile and let's do a record heap allocation. So we can see that memory is a problem. Now let's dig in a little bit deeper. Let's record a heap allocation. OK, again, I'm not touching anything on the website. And memory, 10K, 5K, 10K. 5K, let's hit stop. Boom. Let's try to drill in here on one of these guys. Let's just look at this one. Compiled code, looks familiar again. Oh, wow. It's almost like we've seen this exact 3 lines of code before, right? So again, I know nothing of this website. I haven't even looked at the source code yet, but something in here is already passing a closure to a set timeout, or a set interval. Set timeout is a different operating system. But there's some other stuff going on in here too, right? Like it looks like some other relocation info is going on. I don't see any injections, which is good. So like no one's calling eval, because otherwise we'd probably see the 6K worth of information. Someone laughed. That's probably good. Eval is bad, and you should feel bad. So if you're using closures and eval, just get out. Just get out, dude. I'm gonna see a tweet. Colt says use set interval with closure and eval. Perf matters. Yeah. Yeah, with a WAF, inside of a WAF. By the way, I saw someone the other day that actually had a WAF embedded inside of a CSS. And I was like, OK, that's just a bad idea from all principles, right? Like, so you have the CSS gets loaded, and then the WAF has to be. Anyhow, we see this other part is an array. Now, this is interesting. So when you see this array object, this means this is an actual JavaScript array that is allocated somewhere on the page. And you can see some of it is coming from internal with V8, right, the code deop data. But otherwise, the relocation info, here's like a null. A null array is just being created for no reason, and no items are being added to it. We can go down here to string, and we can see a GM string has been created somewhere. Let's kind of scroll this up. Do we have any information? Yeah, that's what's going on right here. So there's a regex occurring somewhere. GM's being created. And then there's some system level stuff. This is mostly dragons and krakens and other things going on under the hood. If we expand this a little bit, we can actually slide over and see, again, compiled code, right? Oh, there's another relocation info. Let's see if there's a deopt this time. No, that makes sense because the spike's not as high. See over on this guy, compiled code. Relocation, yep, spike's not as high again. So again, deopt is actually what's causing the memory spike here, and then of course that's causing inflation in our heap. So we can actually see there's a couple problems. Obviously they're sending too much data down the pipe. This page is loading slowly. The person should feel bad. They've also got some timers and some closures and some memory leak issues that are causing some friction with their users. Let's load another site. Here we go. Try this one. Chrome, always, thank you. All right, so let's see this one. Who thinks this is going to be a fast site? Show of hands. No hands. Good job. You win. I like the spinner. We're trying to load. We're letting you know that we don't know how to do this. Oh, sorry, that was below the belt. Oh, I'm sorry. I'm sorry. I'm sorry. I'm sorry. I thought it was a good idea. We see it in Gmail. I don't know. It's kind of like, hey, we're not ready to figure out how to stream content yet. We saw it load. That was good. So let's do this again. Actually, let me show. Scrolling doesn't seem that bad. Let's click on something. That was actually pretty fast. That was actually a little too fast. Hold on. Wait a minute. Let me go back. Okay, back was slow. Let me click on something else, like trust no one, right? I don't trust anybody. Wow, that actually loaded a lot faster than the main site. Let's drill in here. Hold on. No, I'm going. Dude, you're messing it up. Jake, who's got the microphone? I didn't interrupt your talk. So let's take a look at this here. So I'm gonna go to Network tab, and I'm gonna hit Reload again here. Boom. We're gonna take a look at this. Let's see what's going on. So it was really weird. The main page loaded slow. That was awkward. But then all subsequent clicks loaded actually really, really, really fast, which tells us if you can't get the main page right, why are you getting the sub-clicks right? That's kind of awkward. So we're still loading. We're still loading. We're still loading. Again, I always sort by size, right? Because I'm a big dude who says that memory is where the performance problems are. We can actually see that they're loading. And I'll kind of give away the punchline here, but these images were on the sub pages, not the main page, but they're being loaded on the main page. Anyone figure it out yet? Basically what they're doing is they're loading all of the images for all of the articles that you would click to before the main page is loaded. So they're basically trading off, right? They're saying your initial load time is going to be really crummy, but every click after that's going to be golden. Right? So they're kind of giving up that initial 3-second load time to get 1-second load times later. I don't know how that, maybe that's a discussion. Again, here's a WAF. Anyone like WAFs now? Answer should be no. But yeah, this is really interesting that we're seeing some of these images. Let me see if I can sort this again and see if we can't get better. Here's another PNG. Again, this is not on the main page, right? So let me hit back here. Let's show you the main page here. Even clicking back takes some time. No? Backy? No? I guess not. We're stuck now. There we go. So yeah, so notice this right here. So this was kind of one of the last things I clicked on, and they kind of have a little drop down. So yeah, basically each one of these items, the images and sort of like the extra content is loaded in the main page, not the subsequent page, right? We're kind of seeing that break down in a lot of these charts here. Right, so they have a couple lower res versions here too. So remember when that 100 pixel by 100 pixel Facebook icon was 9K? Here's a 320 by 180 that's 10K. So again, don't trust your Facebook icons. I would like to say don't trust Facebook, but I'm not allowed to say that on camera. Shit. Sorry. Again, here, perfect. Here's a 320 by 180. That's exactly 9.1K. So again, I think all of you should be questioning how big your images are. But I think this Quartz site is actually kind of an interesting case study because they've definitely traded off one type of load time for another type of load time. And I'm not really sure why or where the ramifications or where the justifications of that are. But I think we can definitely all agree that the 20 years that we've had on the web have all kind of accumulated that the initial load time is pretty much the most important thing because that's the first thing your user feels. Like none of you have seen this site except for the one guy who submitted it, and all of you felt the pain of this site loading for me hitting a button. And it doesn't matter how much the clicks after that are, most of us would have left the site before we got to that. Let me go over here too. I kind of want to show this. So notice this, I moved now, but this YouTube image here, right? So if I click this button, you'll see the red boxes again kind of show up here. So we can actually see that the video is actually being, that part of the page is being re-rendered, right? So you can see again that it's showing that nope, don't care, nope, dumb, stop, let me click, done. What I'd really like to show here, and this isn't really showing up on the main screen, I'm sorry, but can anyone see this orange line right here, this orange line? So one of the other interesting things, there's a talk that I gave at Google I/O this year on this. It's called Web Page Design with the GPU in mind. So what happens is certain elements on a page are kind of, imagine your page is a plane, right? And all of your images and all of your text exist on this plane, right? Some of those things are actually propagated to its own plane so that the web page can actually scroll in the background, and this other plane can actually scroll relative to it, right? So this is relative scrolling content. Let me actually show you this on a big screen here. Let me load up HTML5 rocks. And let's, nope, I typed in the wrong thing. Boom. Because I can type. Who's on my internet? Watch my Wi-Fi go down now. Let's try that. There we go. OK. So I'm going to pick this, just a random article with some random guy on it. Some random good-looking guy. I think he's pretty good-looking. Bald is beautiful, I hear. So let's go ahead and turn on, this is Chrome DevTools on a desktop site. I know I wasn't going to talk about this, but let's do Force Accelerated and show composite layer borders. So turning on layer borders here shows us what we're seeing normally. The first thing you see is that the blue lines here actually represent the tiling of the page. And this orange line actually represents something that's been promoted to its own layer. So how many of you are using Translate Z? Translate Z, Translate 3D. This is the hardware accelerated fast path, the silver bullet that makes your web fast because you're suddenly using the GPU on the web. It's so amazing. Actually, that's not how it works. What happens is when you use Translate Z or Translate 3D, you're actually promoting these pieces of content to its own plane. And this is actually a separate set of tiles. So remember how I said the GPU will actually scroll your tiles on the screen? When you actually use Translate Z, you get another layer that the GPU also controls. Now I'm going to see if I can do this, because for some reason we get paused in the debug. Oh, gosh, too much clicking. So as I scroll here, notice how these objects on the side, watch this. The table of contents has not orange, right? And so once it gets to a certain part, it actually gets promoted to its own layer. The orange border represents different layers in GPU memory. And then as I scroll down the page, they actually stay static. Anytime you have relative scrolling content on your page, you're actually going to want to promote it with this Translate Z or Translate 3D. Now, beware that this actually puts a lot of pressure on your GPU. So for all of you who are just going to start putting Translate Z on every part of your page, we saw this happen a lot because it was supposed to be a silver bullet, every one of these tiles, every one of these layers is actually contending for residency inside of your GPU cache, which means the more of these separate layers that you've actually promoted, the slower your website is going to be. So you get an inverse effect with it, right? Because basically your GPU is getting overtaxed, more tiles are being evicted from your cache because more things are fighting for residency. It's actually going to slow down your site because your CPU is spinning up more. Anyhow, enough with the desktop stuff. Desktop's dead. No one wants a desktop. OK, let's go back over here to this thing, because the mobile web is sexy. What was I showing off? Yeah. So Quartz, this QZ site, it's actually a little bit interesting because we see mostly that as we're scrolling, notice the big red spots that keep popping up. Let me see if I can get it to do that again. Yep, see it? So something's going on. It turns out, I'll spare you the punchline here. What's actually occurring is that these guys are doing something with a scroll handler in here where they're actually trying to catch what I'm doing. They're trying to catch my little scroll. They're trying to reposition things. And as soon as they touch the DOM, the whole DOM has to be recalculated. As soon as the whole DOM has to be recalculated, all of the tiles have to be redrawn, right? So as soon as they try to catch what I'm scrolling and reposition things manually, they're actually invalidating the hardware compositing and the GPU scrolling that we're trying to do on their behalf and actually messing up their entire frame rate. How many of your mobile sites are catching a user input like this? Yeah, I saw that. I saw that. At least you're honest with it. Forecast.io, they know what's going on, guys. I got it right. I got it right. He didn't. No, he still hates me. That's OK. All right, let's do some other websites. Pete, how are we doing on time? 15 minutes? I can load all the websites in 15 minutes. So let's look at a couple other ones here. let's see. Let's take a look at something good so that everyone walks away from here with feelings of happy bunny times. Sorry, I just called somebody. So this is meetup.com. Boom. OK. So we didn't see a loading spinner. That was kind of nice. But it did take a little bit long to load. In general, though, let's see how it scrolls. That's actually pretty fast. Notice let me turn the let's open the DevTools again and see what kind of red things are occurring and what kind of load times we're experiencing here. So turn on DevTools. Let's hit reload and see how the network performs. Not that bad, not that bad. On the device, I'm actually seeing things starting to pop up already. I noticed no WAFs in the code. That's really good. Oh, there is one. Son of a bitch. Where did that come from? Oh, bogus. Well, maybe they're not using that on something critical. Let's sort by content here. This is really cool to see, right? We've actually got a 44K JavaScript is actually the biggest part of the page. I'm surprised that's not jQuery at 191K. How many of you are using you know what? Never mind. Just never mind. OK, actually, this image is popping up to the top. 60K JPEG, 320 by 226. That's maybe a little large. Another 60K JPEG, another 50K JPEG. This is really interesting, too, because we just saw 340 by 226s on the previous site that were about 10K, right? So again, someone's not optimizing JPEGs the right way. In fact, there's actually, on the article that I put on HTML5 Rocks about image compression, let me see if I can tap over there really quick. This article that I did was actually image compression for web developers. The entire point of this article was to talk to all of you in a very frank way and kind of discuss the backstory of where image compression works. Plus, I'm a really big fan of parrots. They're kind of cool, especially the digitally pixelated ones. Anyhow, there's some great content down here about JPEG information. And it actually shows that, here it is, right here. Let me see if I can zoom this in. Oh, nope, too far. OK, so this is actually, I feel it's important to kind of break away from our regular scheduled bashing of these websites, because that's getting a little depressing, right? Everyone's getting depressed. So this is actually a test that an external person did on the websites, on the compression quality of images that are being served by the top websites of the world. And what you're actually seeing here is most of them actually just use a standard value, right? So all window live background images are exactly 82. Regardless of what the PSNR is, they choose 82. It's hard-coded, right? So they might be able, on some of the images, to use a level 64 and actually reduce the size more, but they use 82. Wikipedia are all 80. For every one of their images, regardless of the content quality on it. YouTube is about 70 to 82. That's kind of good. It shows that they're actually doing some dynamic scaling, although it's unclear whether or not that's actually manually scaled, or they have an artist actually changing them, or they have some sort of dynamic solution, like I was saying. Yahoo, 69 to 91. Again, they may have some more responsive version of that. Facebook's are at 85. And Google image thumbnails are about 74. Here's the really interesting. Twitter user JPEGs are anywhere between 30 and 100, which means that for some images, they're actually like doing nothing, right? And some images, they're doing everything. This actually tells me, I don't know if no one's in here from Twitter, right? This actually tells me that they may have something dynamic, actually testing the noise ratio of the compression there and actually serving you the most optimized JPEG at the best image quality possible. So that's really cool. That's really cool to see that someone's doing that out on the web. OK, back to doom and gloom. OK, we were over here. So yeah, so these images probably are a little too large in megabytes. You know, they're probably not optimizing it. Chances are, nope, that's not an image. Chances are they're just using a standard one. So let's hit timeline. Let's just hit record. Let's see what's going on with memory. Not touching anything. Memory's increasing. Not too much. 5.5, 5.6. Again, we've got these timers getting fired, right? Find.js, I don't even know what this is. Meetup script mobile find. Okay, so apparently it's trying to meet me and find me. That's kind of creepy. Mobile base, so that's weird. So they've got two separate timers coming from their own website doing two different things. And again, right, like not touching anything, nothing's happening, nothing's moving. But we're at 5.6 megs. So it looks like a slow leak, right? It looks like there's a slow closure or something being tossed to this. So let's take a look at this, see if we can't drill in. Maybe we get some, oh yay, it is a jQuery library. Can we summon the power of pretty print? Aha! That didn't help. Let's try that again. There we go. Oh, mustache. Interesting. Who uses mustache? Can anyone explain this line of code to me?
It's a JavaScript implementation engine.
Okay.
Bars was derived from it.
So this is causing a memory leak. Can anyone fix this? Not now? OK, that's cool. Take your time. That's all right. We'll get back to it. But basically, we're seeing again. This kind of looks like an anonymous function, calling some factory objects, testing some object definitions. This in and of itself doesn't look bad, although it is calling like another anonymous function down here. Sometimes the pretty print spacing doesn't get it all right. This might actually be sort of a closure and a closure. Right? It looks like we've got one close there, one open here. Something's going on. Any of you who are using third-party libraries, it's actually really easy to fall in these traps where they're allocating memory and doing stuff on your behalf that may be negatively impacting your performance. And we sometimes ignore these faults and don't track these faults down because of the fact we get like event propagation or something else. Like, oh, I get a callback when something occurs. You know, that code you can actually write in about 100 lines of your own making and can actually keep it memory performant. But instead, we kind of pull in these large libraries. So it's important that you know these trade-offs when something like this is occurring. Let's do another website. Pete, we got what, 10 minutes left? Yeah, about 10 minutes. Let's see, what haven't we done here? So I have to load this because I really don't get this website. I really want to talk about the website more than the performance characteristics. So this is called Game of Phones. Is this your site? OK, cool. I really don't get this website, but it's here, so we can take a look at it from a performance perspective. Basically, what happens is someone will record, and from what I can tell, they're like very politically charged, angry arguments. And like you sign up, and someone will call you and play this recorded message that's like, you know, blah 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 blah, rally, fight the power, and then like you have to call someone else on the list and like try to regurgitate what you heard. And so it's kind of like the game of telephone, right, that you play as kids and you're trying to like get all the way through. I have no idea why people are even doing this. Like I hate getting calls from my wife, much less random strangers on the internet. I'm on the internet because I don't want you to call me, right? Like send me a text or something. Like anyhow, personal thing. I'm sure it works for your brother. I don't get the internet. I'm too old. That's my problem.
I've had people tell me it's the only phone calls that they will answer. We have answered phone calls from this and from their mom.
Oh, dude, Game of Phones, awesome. You know what you need to do? You actually need to get the voices from Game of Thrones to actually do the call, and then it would just go through the roof, dude. HBO might sue me now. Sorry about that. Anyhow, let's look at this from a performance perspective. There's really nothing on this page. I mean, it's kind of text, but we're going to run through it anyway. Just so you guys can kind of see like the differences in these things. So am I here? OK. By the way, did you see actually what showed up? Was this on the screen? Sorry. So this is Game of Phones. Again, it's just text, and people calling each other. OK. But this is it. 12 requests. What the interesting thing here is 107K. That's a little odd, right? Like we were seeing some other pages come in below that. Mainly, this is coming from concat. So I mean, Bootstrap is being included. I'm not really sure why this needs Bootstrap. I guess the cool kids are doing it, yeah. And here's the funny thing: we got like Bootstrap min, and then like CSS that replaces Bootstrap. So that's a thing, and then jQuery. I'm not. OK. And then here's another Bootstrap again, and then TelephoneGram, and then another jQuery. Are you using two jQueries?
I should mention that I've never made a web page before.
OK. You're using two jQueries. Do you know you're using two jQueries? No, you do. OK. And then I like the GIF, right? It's sprite sheeted, I guess. Here's the cool thing. So a 300 by 120 animated GIF is only 4.4K. Yet we were seeing like full JPEGs that were like 9K that were static, right? So I'm not really sure what else to do with this. Let me hit timeline. Let's see what this is doing here. It's kind of a little awkward. So your jQueries are using memory. So this is kind of telltale, right? Like Do you have a timer on your? It looks like you have a timer on your.
Maybe the audio player is using it?
Maybe the audio player. Yeah, it looks like. Yeah, it does. So it looks like there's a timer here. I don't know if you guys can see this. It looks like there's a timer here, and you can see this red square up here, just the play button. Just like that play button has a timer that needs jQuery and Bootstrap, 2 jQueries and Bootstrap, and is allocating like a meg of memory over like 7 seconds. So that's a thing. Lots of rasterize occurring in here. Lots of recalculates. So not only is it repainting, it's actually it's like updating the DOM to repaint. Let's look at this again. That's updating the DOM. Don't know why. Maybe there's a cool jitter effect there. Like maybe, you know what, maybe I got this wrong. Maybe this is like, I'm actually looking at the matrix. Am I looking at the matrix? That would be kind of cool, like if I'm like analyzing this, sorry. I'm having fun. It's late and I have to keep you all awake for like another 5 minutes. So anyhow, I don't like this trend. Like you're actually allocating more memory faster than the other websites we looked at. It's probably because you have 2 jQueries, but anyhow, let's dig in. So let's go to profiles again, follow the memory, find the performance problems, right? So we follow the asset memory to figure out where load problems are. We follow dynamic memory to figure out where compute problems and render problems are. Can I click this button, please? Clicky. You've allocated too much memory for your site, and I can't click. Oh, there we go. Okay, so let's do record heap allocations, hit start. So that's kind of interesting. You guys see this pattern? So this is actually really very, very regular allocations that are occurring. 2 different sets of it, but they're almost deleted immediately, except for the stuff that happened at the beginning of the trace. So see, we're seeing the gray lines, right? So the gray lines mean that what was allocated has actually been freed now. This is kind of odd. I kind of want to see where this is coming from. You know, I like to dig in and figure out why I'm so bald. So we have the whole thing, yada, yada, yada. Let's actually just highlight this guy here. So array, what's transition array? So there's something's going on inside of V8. All these are being deleted. Compiled code. Is it deops? No, relocation info. So it looks like there's just some sort of cases where jQuery is executing. Again, I see this a lot with closures. Closures, for some reason, tend to bring up this pattern. Like jQuery is kicking off a closure that's causing a reflow of your entire page for like a 5 pixel by 5 pixel icon. So you're still loaded faster than the other sites. Bravo. Round of applause for that.
Real web pages don't need images.
Say again?
Real web pages don't need images.
Yeah, there you go. You know, I'm a fan of the text web. That requires drinking to get more information out of that. Anyhow, okay, let's load up another one. Pete, how are we doing on time? 5 more minutes. Okay, let's clear up quickly because I'm actually really interested to try this Robitussin and whiskey thing. Like, I think we may have something on there. Okay, let's try. Here we go. Let's try this CBN week. And we're done. I think at this time I don't actually need to tell you guys what I'm about to do, right? This is, no, I don't want to translate. I used to be able to speak Chinese. It was a beautiful language. You kind of know what I'm about to do, right? Like, I'm going to load up networking. I'm going to see what images are too large, what JavaScript is too large, what you're using that you shouldn't be using. We're going to try to cull assets and get rid of extra networked loads. I thought the points about sprite sheets was perfect earlier. By the way, they shouldn't be called sprite sheets. They should be called atlases. You should actually see my Udacity course rant on this. Everywhere else in the world, and video games and film and everything, we call them atlases. You know what? Never mind. Anyhow, let's see some scrolling. Not that bad. Let's head over to DevTools. Let's take a look at this under the microscope, right? Let's go back to network. My computer said I'm done. All right, this will be the last site, and then we'll actually get to all the questions. And I think we're going to do a group question, right? Fantastic. So that's interesting. So there's already 89 requests, 92 requests, 93, 95. 1.5 megs transferred so far. 1.9, 2 megs, 2.1, 95. Let's see if we can go upstairs. So here's something interesting up here. So notice this gray bar right here. So in Chrome DevTools, when you look at this network tab, basically you see 2 values. You see sort of this semi-transparent and this opaque portion of these items. That semi-transparent value is actually how long the browser spent waiting to receive the asset. This is one of the reasons that sprite sheets are actually so important for you, because the browsers, each browser has a set number of limits of open connections that it will allow to a single server. For Chrome, I believe it's around 6, right? Which means if you have like six requests in flight, it'll block the rest of the requests until a slot opens up. Think of it like a caching FIFO or whatnot. And so Chrome actually shows you this here on the timeline. You can see like some of these actually waited a very, very long time. In this case, it was actually spent, what is this, 471 milliseconds waiting. It wanted to request this asset, but it couldn't because there were other things around the pipe. And you can kind of see that this is a function of the fact that there's about 100 requests and 3.6 megs transferred. For those of you who don't know, the average website size right now, according to HTTP Archive, is about 1.1 megs. And that's for desktop. They haven't really got into a lot of the mobile testing just yet. But obviously, mobile shouldn't be 1.1 meg, right? So obviously, there's too big a content here. So let's see if there's any big offenders. Let's see if images are a problem. Who thinks images are a problem? Here's a 300K image, 200K, 197K, 161K, 152K. What is in that image? I think that's bigger than raw. Yeah. Obviously, these images are too big. They're not being optimized. This should be fixed, right? Let's take a look at timeline. Let's see if anything is going on with memory here. Anything crazy? Slow. Again, timer. We see this same pattern. So we see almost all of these pages are falling into the same pattern. Also, almost all of these pages, and some of them, in rare cases, are all using jQuery or jQuery twice. Closures are being passed off to timers for things like ads or analytics or marquees, and these seems to be like a common pattern. But this is obviously causing a lot of memory and a lot of churn and some other weird things going on. I can look at the frames times here, and so let me actually do this. I don't know if I showed you guys this tool. Cancel. So as I'm scrolling here, and it's not that picking that up. Okay, never mind. I won't show you that tool. Anyhow, let's be done with this for the evening, because I think Pete has some other stuff he wants to talk to you guys about tonight. Thank you for your time tonight. Perf matters. Wait. No, I'll let you start the clap in a second. So here's how you get a hold of me. If anything today was controversial or something worth tweeting or something you just want to ask more questions about, go ahead and find me. Make sure you join the Google Plus Web Performance community. There's a lot of great stuff there. Please, for the love of God, use Perf Matters. Follow the Perf Matters. It's a brand. You should wear this at work. Okay? Everything you do, you should be challenging your employees, your managers, the owners of your company. Perf matters, perf matters, perf matters. It's going to be the thing that separates the billion-dollar companies from everybody else on the mobile web within the next year. In fact, it already is. It's already separating us. Challenge everyone. Hold them to the standards of Perf Matters. Now you can start the clock. Yes. Thank you for your time.
Thanks, Colt. That was awesome. OK, so we know it's late. We're going to have a quick Q&A with speakers. If you're ready, we're going to put some chairs. You can come sit down. We'll make it quick. And you share a mic. OK. Runner? Joe, you want to run? OK, questions? Anyone? OK.
This is directed to the weather application.
And by the way, I'm really glad you didn't look at forecast and try to benchmark it. Really glad.
I just would like to know what is actually keeping you from porting it to the web, and why not? And
what do you mean?
Shouldn't you try harder? You say you can't port it to the web; it has to be an application.
Well, I mean, it doesn't have to be, right? But I don't know anyone who would be willing to check the weather by going to a website. It just takes way too long, and there are so many good apps out there that it's just not something people are going to do, and at least not in large numbers. People may try it first, but I don't see that happening. And that's definitely not true for most things. I think it's a weird thing for weather in particular. maybe I'm just, if it's so awesome that it's the best website in the world, people would go to it. But I don't know. That's the one thing that native apps have over the web is the ease of accessibility, and they load super fast. It doesn't really answer your question.
I could go on, but next question.
You had a question yourself, right?
I did have a question.
Talking
Sorry. Is Colt short for something, or is your name just that awesome?
Thank you, first off. Colt is short for Colton. I was actually named after the 1970s show The Fall Guy, Colt Seavers. Yeah, it turns out my parents were geeks before I was a geek. By the way, go Colts.
Okay, we have another question from the crowd.
Question for Colt about the PSNR, is that right?
Yeah.
Do you know of any command line or open source tools that can do a little bit of that iteration and kind of as a trade-off of time versus precision, give you a good compression?
Yeah, absolutely. So pretty much every single JPEG compressor will do that. A lot of so the question for the people at home, in case they didn't hear it, is do you know if there's a command line compressor for JPEG that'll actually give you this evaluation of PSNR and how much it takes to get that value and whatnot? Pretty much all of them do. If you actually go out and Google image compressor comparison, the first 29 pages you'll see are just going to be charts of PSNR against file size against time to compress. So things like libjpeg, JPEG Turbo, these are kind of the top tier. And like I said, one of them is actually used inside of Chrome because of its speed. And I think there was actually a news article a couple weeks ago of Apple actually acquiring I think it was a Scottish company or an Irish company that all they did was make a faster JPEG decoder for the iOS platform. And so, they are now all living in mansions with waterfalls inside of their mansions because they just made a JPEG decoder that was faster. So, but yeah, definitely check those out.
So I do have a question about the special font files for Colt, the WOF, I guess, or whatever, whoever knows better. And like Font Awesome, which some people use for icons and whatnot. What's the suggestion? What do you do?
What, in terms of what you would do for
You don't
icons?
use them at all, or how do you avoid using them if the client wants a specific pretty font, or what do you do?
So I would always avoid using web fonts for body copy. You can almost get away with it for things like headlines because the chances are the user has some idea of what the headline is going to be. They've either clicked it from the previous page or they've clicked it from search results or something like that. The problem is when it's there for body copy, because that's when not only is the user going to have to wait for the CSS to see anything, because there are very few resources that are going to block your first render. It's JavaScript if it's done wrong. It's CSS all the time. And it's web fonts. And the problem with web fonts is their loading is triggered by the CSS. And it's going to happen after layout. So your CSS downloads, there's a layout done, and then it goes, oh, I need to download a font. The font downloads, and then it can render that text. I would say avoid for a body copy. You can use Web Font Loader, which is something developed by Google and Typekit. And what you can do there is it will use JavaScript to load the web font, and it will give you special class names on the HTML or body element, I forget which, that indicate the loading state of that font, and you can then decide to use a different font while it's loading. You can force the kind of what Internet Explorer does, but it means you can tweak the size of the fallback font to more closely match. Change the line height, change the size to more closely match the font that'll load in. So you can do that with headlines because they tend to be like one line. You'll struggle to do that with body copy because the user will be sort of reading a bit, and then the chances are things are going to jump and it's going to be the word is going to move along the line, or worse, it's going to wrap differently.
Next question.
Yep, it's for any and all. We saw a lot of examples that was pretty easy to detect performance issues with file sizes and number of network requests. Increasingly, we're seeing sites that the perception of page load is just as bad as the actual throughput. So can you talk a little bit about how you would analyze and test for basically all this crap that's being done when DOM is ready and people are just loading stuff after the initial load, and there's all kinds of junk happening with JavaScript? How would you test and analyze that kind of thing?
Well, first I want to pick up on something that Colt said, because I think it's worth saying again, that if your site has a loading bar, in 99% of cases, that's a missed opportunity. You're doing it wrong. And I include Gmail in this as well. The fact that I have to watch a loading bar go to see a set of email subjects, which is just a list, it's essentially an HTML list of a sentence, is kind of ridiculous, right? And if you compare something like TweetDeck to Twitter, I mean, Twitter do this, they serve HTML and CSS, you get the content as it's loading, whereas in something like TweetDeck, you get this loading bar. So pull script out of your, avoid depending on script for first render, I think would be the first case. But I don't know, do you have anything in terms of how you would sort of test that, or like any continuous integration for that?
Telemetry. We didn't really get a chance to talk a lot about continuous integration tonight. I think Jake and I both agree that probably the next big step in web performance is getting a good tool out there to allow you to do performance continuous integration, right? So you should be able to have some distributed team checking in code changes to some GitHub or something like that, and then some automated system will actually kick off a build, and then once that build's done, it's run across a continuous integration environment across different web servers and different mobile devices, and actually give you performance information back, not just from the network side of things, but also from the rendering side of things, the JavaScript side of things, post-load AJAX style information as well, and be able to give you that in a report, so you can actually go back and be like, hey Jake, you broke the perf build, dude. I think this is actually the next step in tooling for the web, and I think we're pretty far away from it, unfortunately. So I hope that there's a lot of people thinking about this problem.
Next question.
Oh, sorry. So the set timeout, instead of that, you should be using for polling, for daemons, for
So set timeout in itself is not a problem. I'll say that again. Set timeout in itself is not a problem. The problem is passing a closure to set timeout, right? So obviously, if you're using a closure, there's a chance that you don't know why you're using a closure, or you're using a closure because you think it's a better coding pattern. I mean, it seems to be a pretty standard coding practice when you go to, you go copy paste off of the web. I mean. Again, the set timeout, the set interval, not the problem. Feel free to use set interval. Yay, set interval. Woo! The problem is set interval plus incorrect memory management or closure is being passed to set interval. That's the problem. Is that?
So what I would say is if you're doing animations, you've got this assuming 60 hertz screen, you've got this 16.67 milliseconds window in order to produce what you want to produce and then get that on the screen in the next refresh. If something else on the in the page is running a set interval, I'm assuming you're using request animation frame for your animations, which you should be, or CSS animations. But if you then have a set interval or something running, or some other things using set interval, even if that's only going to take 3 milliseconds, if it happens in the 3 milliseconds when there's going to be a new refresh on the screen, it is going to block that frame from happening on the screen, and it'll drop a frame. So if you're doing like a set interval, if you're going to do some work inside that, putting that, you do your set interval for whatever you want, like every 300 milliseconds, whatever. If you've got some substantial work to do in there, or really any work, use request animation frame in there as well, because it'll queue that stuff up for the right at the start of the refresh, and along with maybe other timers that just happen to coincide roughly at the same time.
In fact, really quick on that. So there's actually a design pattern that I don't talk about a lot because people throw chairs at me. But if you actually take so a lot of people are actually handling input when the user actually gives them that event, right? So you click, I get the on-click event, and you go, cool, this is an event, let me run some code right now. That's actually a bad idea as well, because again, you have to remember that the web page and the browser is going to come along at every 16 milliseconds, and it's going to try to, or whatever the refresh rate of the monitor is, and it's going to try to repaint and refresh the screen, right? But if that JavaScript is in the middle of executing input or set intervals or anything, it's going to block that from occurring. And so there's a different design pattern that we've seen very successful, and we see it with game developers especially, is that you don't actually do any logic in callback handlers. Instead, you actually just kind of cache that value away, and the next time that your request animation frame comes around, you actually respond to that. And so if you want to get rid of this set interval system, just put all that logic in a request animation frame. The differences in whatever your interval you think your interval needs to be, and the 16 milliseconds that request animation frame comes around. I mean, come on, we're talking about polling data or other things. So it's a different mental model. So.
Okay. So unfortunately, we're out of time for questions. That's our show for tonight. So, did we? Yes. Okay, so our next event is going to be our Hack Day. It's going to be November 16th. It's going to be right here, TimesOpen and NYT Devs to follow what we're up to. NYT Devs is the main one on Twitter. You can also visit our site, developers@nytimes.com. I wanted to thank our speakers. I want to thank the team that planned the event. They're all wearing purple shirts. They can all wave their hands. And Pete LePage from Google, who's standing there carefully looking at his camera. A lot of work went into this. And we want to thank you for coming. It's been a great night. Go make your websites faster. We're good? Oh, yes. One other thing. I've heard rumors.